Looking back at when I started learning Houdini, most of the videos, tutorials I've seen, they were a little bit advanced, and I couldn't wrap my head around so many different aspects of what's happening. Everything felt so alien. So what I tried to do in these, I don't know, 8 hours at this point, I don't know how many I recorded. I tried to look back at where I started and try to put my head into a total beginner, and I went from there. So this is what it is. I hope you could learn something from it. At least it'll get you running, and then from there you can start looking into more advanced stuff. I'll leave more links in the description, and you can dive into things like Vex and all of that after you go through the basic nodes and how things connect and all of that good stuff. This recording is done in 2019, so it's a little bit outdated, but like the curve tool, for example, you can just try to work around that. But for the most part, the information is pretty beginner level, very basic, fundamental stuff. It's nothing has changed dramatically there. So good luck on your journey, and I'll probably see you in another video at some point. I don't know.
First, you need to go to Side Effects, Products, and download Houdini Apprentice. It's the free version of Houdini. Once you have it, this is how it'll look when you first open it. Any key I'm gonna be pressing, you're gonna see down there on the left, right. One thing we need to make sure of is we have the Side Effects Labs toolset. If you don't, you go to Shelves and you add the Side Effects Tools. There, Side Effects Labs. You add that shelf, and you go to that shelf. You click on that button up there, and you hit. Now that we have the labs tools, let's start making stuff. First, I need to configure the layout because I don't really need some of these stuff, so I'm gonna close that. I don't need the timeline for now. Parameters, just delete it, delete that, delete this. Okay, this is all I need right now, and let's hit B right here. You'll know why. So these are the parameters up there, top right. That's the view, and here where we'll do all the work. You might have tried typing in like box or something, or maybe some of the labs tools like say edge damage or something, and you cannot find it here. So the problem is we're inside object level right now. If we put down a geometry and we go inside, double click to go inside, now we're inside geometry. So everything we do here is the things you're probably used to in 3ds Max and Maya and Blender. So these are the surface operators, SOPs. So if we put down a box, now we can do that, and a sphere, that's a split, a sphere, and so we've got also the test geometry. These are Houdini specifics. You've probably seen this like a million times. If you hit on the display, you can see it in the viewport. That's Tommy. He's like the Unreal mannequin. Good for scaling, 2 meters. If you press 1, 2, 3, 4, 5 will show you the UVs. 4, yeah, almost 2 meters. Okay, so these are the parameters top right. we could uncheck some stuff and maybe low res, W, wireframe, shift W, wireframe on shaded. So W, shift W. I think that's all you need to get started. You have the viewport, you have the network editor, and also the parameters. So any node you select, you'll see its parameters up here. And just try and change the things. So maybe I'm trying to change this, but nothing's shown up. It's because I'm changing the box. See how it's highlighted in yellow? I'm changing the box, but I'm not displaying it. So I need to put the display render on. I can either select it and click R or go to this. So see how it's bigger now because I was changing the scale. So any node I select would show up the parameters, and I can change them, and you need to hit display to see it in here. There's other options in here. You could click on this and it'll show it in a ghost view. That will bypass it, so it's not gonna work, it's just gone. And if I hit it again, it'll show up again. So let's see that again. Yeah, and you could also click Q to do that. The bottom one it's lock. I'll get more into that later, but lock in general it's just caching this on disk, so it's actually saving that as is. It's no longer a node, it's an actual geometry box. So this locking things would make your file size bigger, and we'll get into that later. What I recommend now is you right click and see all of these things. These are the nodes you'll be using. Not all of them, of course. Most of them you don't really need, but the ones you should focus on for now is the ones under polygon, these ones, because these are the operations you're used to in the modeling packages. Once you're done playing with these, go to labs and try these out, see what they do. So these are game specific tools. They're made for games, but you could use them for other stuff as well. Let's build more stuff. Now we have separate nodes, but Houdini is known for building networks, things with connections, graphs, huge graphs. For example, let's put down some of the labs nodes and let's see, for example, let's try, I don't know, labs curve suite. And double click, you go inside and you see this big network. And right now it's grayed out, you cannot edit those nodes, but so you know that the labs nodes or most of the other nodes, they're made of already existing nodes. So you can dive right in and see what they used. So for example, here they used a null node and they named it input. They used the convert, etc. So these are already in Houdini. You could replicate this whole thing. You could make your own tools and then package it and reuse it in other files and other projects. You could give it to your friend, to your team, and they could reuse this same tool and make things out of it. So this curve sweep, if we put down a curve and draw something, put that in, see how this required backbone curve, this red arrow, it needs an input. So put that in here, and yeah, you hit space to go into the navigation mode. So we could change the uniform, and this makes you a cube, a tube thing. Okay, so you see how now we have a connection between those two nodes. we could start making more connections. Maybe I want this box to be connected somehow with these two. I can put down a merge, put that in here, that in there, hit display, and now both of them are in the same network. Let's try the null. We saw this earlier in here, up there, and the null does literally nothing, just nothing. It's for cleanliness sake. You could use it to, let's say I have this network here, and you hit Alt and drag, and this other network here, but this network is just really far up there, and this network is here. So you could use null nodes to organize your things. And another way to add a merge, you select both of them, hit Alt, and drag one of these, and it'll merge them. And now everything is merged. Well, the pig. We could do that here again, and rewire this to the merge. And now everything in the scene is in the same merge. We could put down a null, and in this null, we could name it out, or ut underscore, and everything if I can type. Okay. So the reason you put down a out like that with capital letters, it's easier to find later. So if I put down an, say, object merge, and I try to look for it, see how it's up there? The first thing that shows up are the capital letters. So if I hit accept and I hit that display, so this object merge, it's sort of like a teleportation thing. So you don't really need a wire. I don't really need to wire anything in here. See, it doesn't take an input, it has an output. But the input is in here. It's an object merge which just references some other node somewhere else in your graph. This is why right now, although I'm not selecting this, I still see everything. If I delete this, it's gone. You could reset this with Control middle mouse. And if we want to see the connection, the hidden connection, we could go to View, Show Selected Nodes, and now you could see how this arrow is pointing from this node to that node. It's a hidden connection. You don't see it. Once you click on it, you see it. But usually it's turned off. It's hide, because once you start having so many hidden connections, things would get crazy. If you try to select everything, you would see like so many arrows, and yeah, that would be not very useful. That's why it's put on hide. Another useful thing for organization is if you press C, you'll get this color wheel. And now I can color this, let's say blue. That I like to color the outputs with black. And anything that is just might be an error or something that is really expensive, I would color it with red. But that's my preference. You could use this the way you want, and then from afar you could see, oh, this node is black, probably this is the output, and you go to it. Yeah. let's export this mess we made in here. I love this, and I need it right now. I need it outside Houdini. I need to use it in Unreal or something. So I can put down a file node. Before I connect anything, I usually bypass it, so it's off, it doesn't export. I put that in here, and type the place you want to export it to. Let's say that's the place, and then .obj, and if I hit the bypass button, it'll export automatically. So this node, it'll just do it like whenever you go on display and select it, it will export automatically. So just be careful with this thing. There's another way, it's an FBX, but the problem is that this is only for indie Houdini or commercial use, that kind of thing. So you probably cannot find this in the Apprentice version. So no FBX for Apprentice. You just use the file with OBJ. But I think this is more than enough if you want to start learning about Houdini. And once you're comfortable with it, let's say after a year or so, and you want to start making commercial products, you could use the indie version, and the indie version is about 200-ish a year. And that price, of course, might be different from the time of the recordings, so check that out. Oh, and you could also like just select this and click wherever you want, and in the end just type in .obj. Part 2, modeling. Let's begin by modeling this window. I'm gonna put I'm using PureRef. Okay. So it's literally a few boxes and some more boxes in here. And maybe 2 cylinders on the sides. I've already made this, and I could show it to you later, but let's first try to build it ourselves. Okay. I'm gonna put down a box. And if I hit enter in the viewport, I'll get the handles. I'll use the red ones. And with shift, I could scale both sides. If I just use one, it'll scale just one side. Okay, I'm happy with that. Alt drag and Alt drag. Now they're on top of each other, both of them. I'll move one of them up. Select both, Alt drag, merge. Again, I'm just gonna move it a bit here, scale it down, up, scale up. Maybe something like this, a bit smaller. I'm gonna delete this one, drag that, and move it. Okay, space and exit so you wouldn't be controlling any of these, and enter, you go back into this. And with Y, you can switch between all of them. Maybe I just need this. The other ones might be distracting for now. Okay. So we need, let's do that small thingy. Do that, enter. merge it, of course. Let's use copy and transform. P to open that. Okay, let's go up a bit. Copy it another time, that whole thing, but this time I'm gonna move it to the side. Okay, we need one more of these. Something like that. And now 2 of these. Sometimes it's easier to control it from there, but sometimes you want to go in to the viewport. Okay. You can hit and hold A and drag, and it'll line them up. I'm gonna merge these two and take the merge in. It would be better if these were those extra ones are under their own merge, and finally their own merge in here. Maybe do the same here. And Y, delete those, cut them, and then this in here. If you select the merge, you can change these, so it'll switch the order of the wiring. Okay, let's move this one to the left, to the right. Enter there and move it. Okay, so this, I need to copy and paste it twice down there, because it's more than once. 1, 2, 3, 4. So copy and paste. I need to go downwards. 1, 2, 4. Okay, maybe a bit more. Yeah, something like this. And now we could just bevel everything. Just a small amount. Shift W for the wireframe. And yeah, if you click and hold middle mouse, we can change with better increments. Exit, escape, sorry. And now it looks kind of weird, so let's do some face weighted normals. If we could connect a normal and go to by face area, now get this smooth look, and maybe you want to color it. Something like that. Done. Easy. Now we could always spend some more time and make it a bit nicer, like add some extra detail. But for the sake of this tutorial, I think this is more than enough for now, and we'll dive more deep in the upcoming ones. Yeah, let's discuss UVs for a second. Right now, you could literally just add an auto UV and that'll solve. For the most part, it's good enough. 5, hit 5 to go here. 1, go back, and let's visualize it. UV visualize. See, the auto UV is not bad. Like, it'll give you pretty nice results, and afterwards you can do some more edits. Maybe you want to change the layout. First, I always color anything UV related with purple, because they're such degenerate creatures of darkness. And okay, let's do auto UV and change some parameters on here. And I want to visualize, go to UV visualize and click on the visualize islands, so it'll color them, each island. I don't need this for now. Yeah, see how the auto UV, yeah. Right now it's not ideal. I think I like this. Yep. And let's see how it does after the beveling. Let's see it there. Yep. So before the beveling and after. Not bad. So there's some problems here. Let's try and fix those. After some tweaking, I found that you could either increase one division and it'll unwrap nicely. But if you want it to be a bit more optimized, let's keep it on 1, but you would have to wiggle that out, move the auto UV, put it down there. So you would do it after the beveling, and now you wouldn't have these weird connections there. With just a couple of nodes, you could start creating basic primitives, basic shapes really easily. And one thing I really like to do, especially with stylized things, I like to use lattice and deform the object a bit, because this is just too mathematical, too straight, too rigid. So let's do lattice, and lattice needs 3 inputs. The first is the actual geometry. Then for these two, you need to wrap a thing around your object, your geometry, and then deform that thing. And this way, this node knows how to deform this object. So we could put down a box and pipe the box in the second one. But the problem is that the box is down here. It doesn't encompass the whole object. So what we could do is we could wire our object into the box, and now the box wraps around the object. So one thing you would also need to do is subdivide that box, because without any subdivisions, there's not enough information to deform. So yeah, I hit W to show both this and that at the same time. A subdivide, we need to go to the last one, open subdiv bilinear, and now we can add more subdivisions. So I'm gonna ghost this and visualize that, or the other way around. Now we could see how the box wraps around. Okay, let's do an edit here. And now we'll edit the box itself. Hit enter in here. And we'll go to, so we've got 2, 3, 4. Let's do 4, or maybe, yeah, let's do points. We'll move the points. So with 2, you select the points, then hit T. And now we could move them. 2, select T, move. 2, select T, move. I'm happy with this. Yes, I am, sure. Okay, let's type that in here. Oh, one last thing, put it on points. Not lattice, points. Exit, escape, and I like to put down a null in the end. And there. Looks kind of weird. So another way, which I prefer, is instead of edit, let's use a mountain. Yeah, a mountain. And we'll pipe that in there. So see how the mountain kind of like warps everything? And this is exactly what you need for stylized assets. You need some deformation. So you get this dynamic angles. So this is useful. This is probably gonna be used multiple times on more than one object. I'm gonna shift O this. This is my asset. This is the window. I'm gonna type window. There. I'm gonna put a null in here. Put that there. And all of this, Shift C. And now they're inside a subnet. I can easily Alt drag it and use this subnet somewhere else. Let's use it on this mess we had earlier there. I'm gonna take it and go all the way here. Put that in there. See how it kind of deformed everything? And the reason it was able to deform everything is because this box wrapped around the whole thing. It's not wrapping around the window, the previous window, it's wrapping around this geometry. So we just made a tool. This is a tool we could reuse on all of our assets. And maybe we could call it something like lattice deform. And we could reuse it on all of our assets. Let's look at a few operations that you would be using in other 3D software. I put down a few nodes and I got them from the polygon tab and the primitive. So on a box we could polybevel, increase and decrease the roundness, and you could change the roundness to other type of things. And there's also an exclusion, and this is depending on how harsh the angle. Right now everything is 90 degrees, so everything is going to be bevel. Got subdivide, poly extrude, and we could select which parts we need, enter, hit enter, in and out, like that. We've got some inset, of course, and some divisions. And with the divisions, there's a spline that is really nice here. You could change how you wanna extrude the thing. Fuse, it's mainly useful when you have close points next to each other, but they're not fused. So you would, if I increase, everything would start fusing based on proximity. Polywire, this is good with a curve. Let's put down a curve. Hit enter and draw something. Polywire, and you can go back to the curve and change it, and the polywire would update. Increase the subdivisions, and let's try the bevel now. See how, because if I turn this off, everything would be beveled, but now it's only gonna bevel the sharp edges. Okay, let's go for the polyfill. Before I polyfill, this will fill an object. So let's make a hole first. With the blast, you could select and hit enter. Now the polyfill would literally just fill. Boolean, you know what the Boolean does, so let's try it here. And we've got a hole now. That's our original curve, and it's subtracted. You could intersect, union, so it's actually welded in now. There's shatter, it'll cut where it's supposed to, and there's stuff on the inside as well. Let's try clip. I'm gonna keep this at subtract, but at the clip, you can literally clip and pick whichever direction you want. Let's do a mirror. These two are good together when you clip and then mirror. Now you can work on only one side and it'll replicate on the other. Reverse, if you had reverse geometry, reverse is good too. And in the end you add a normal. There's also soft and normal. This is good if you have seams, if you UV the thing, and this would give you the option to harden the seams. It's good for game engines. And in the end, you divide. Before you export into a game engine, you need to triangulate everything. So a divide would be good here. Poly bridge. So this, let's try. Doing something like this. Put down a transform, move this to this side, maybe flip it like that, and merge these two, put it in here. Now you need to go into the poly bridge, and there's two groups here. The first, the source and the destination. So with the source, I'll go to edges, hit enter, and the destination there, and hit enter. And now they're bridged. and there's divisions. I think this will get you started with all the basic modeling operations. Now that we modeled this window, let me show you the window I already made for this project. This is it. That's the graph for it. And here are all the rest of the geometry. So each of these boxes contain one of the assets I made. So with this, I could literally Control F and look for things. Let's go for this one. Because I named this vent A, I can look for it. Control V and see it. Yeah. So this thing is that thing, the red thing over there. I think there is another one, then the white one. Yeah, let's go for that. Yeah. And the reason I have some vertex color on them is I'm using those in the shader in Unreal. So now we could, let's say I like this and I want it inside my own file. I could literally just copy this whole thing and go in here. This is our file. Control V. And everything comes in. You don't need to import and export anything. You could just copy and paste from one folder to another. I just right click on and went to the properties of the file, and if you could see, it's literally nothing. It's 262 kilobytes. And the reason it's that small is we're not actually storing the geometry itself. We're not storing the position of each point in the scene. We're storing an ingredient and a set of instructions, and Houdini would read that instructions and it'll create it for you. This is why sometimes it takes a little while to load the graph, because you had a lot of instructions, and every time you switch from one to another, it might need some time to process these instructions. This is why it's a bit laggy sometimes if you have so many different interconnected things. Now, before you get scared of this whole thing, this might be too much if you're just starting out. This is not that different from what we just made in here. I'm gonna display that. And now just imagine that this thing is literally this thing, but instead it's like, let's delete that thing, put that there. It's maybe 3 times bigger. Just think of it this way. It's not this giant thing. It's just these small little instructions that we made, but it's like 3 times the size of that thing. Think of it this way. It's not too much. Like, we could isolate this part and we could go through it separately. Let's do this. Shift O there. Put it out there. And let's just look at this part. So we have a box. Okay. And on this side, well, we have smaller boxes, but they're beveled. So it's also a box. More boxes. We used this. We did the copy and transform. And this is another box in the center, but this time I used a Boolean. Okay. there's a boolean, and we cut those, and another boolean, and a bevel, and I boolean these out from there. Okay, another bevel for these, clip to add an edge loop, clip to add another edge loop, clip, okay, and a mirror. Okay, so these are your basic operations. Like mirror, it's like the symmetry thing you use in Maya or whatever modeling package. Clip. Oh, I see. This is why I cropped this part, because it had these faces. Yeah, clip either adds an edge loop or just clips the other side. Let's try and use it. Clip. There. I think it has a handle. Yeah, it does. There. Yeah. And if you go to all primitives, it'll get both sides and it'll keep the edge loop in between. This side, the other side, all of them. And the clip is one of those polygon I talked about. Yeah, there it is. Clip. Okay, we have this now. What do we have on this side? Some boxes with transforms. On that side, I just added that more boxes in here, and there is some UVing, and this is the lattice thing we just created. If we go inside, double click, go inside, yeah, same thing I used in here. Auto UV for some UVs, merge it with the other thing. Okay, so this is a curve, subdivided the curve. Okay, polywire, auto UV, and UV transform. Okay. What about this side? What do we have here? Some, okay, how would it, circle, extrude, clip, another extrude, group two primitives and extruded them. Okay, and bend, and copy. The nice thing about copy to points, it'll copy 2 points, not copy and transform. So if we have a curve, I can take whatever object and copy it to the curve, to the points on the curve. And in the end, once I'm done with this, I use a transform and put it to 100. So now it's way bigger. Just for Unreal. Unreal Engine prefers centimeters. Here we're using meters. So, and then name it something. That's a null, but I colored it black. And also hit Z and use this circular shape. And finally, I used an FBX, but you cannot do that with Apprentice, so all you have to do is just use a file. But remember, bypass first, put that in, put it to right, wherever you want, and hit OBJ here. Like, pick whatever and OBJ. And then remove the bypass and it'll export. Okay, so this wasn't as bad. Like, see, it's not that, it's just a lot of things stacked on top of each other. It's same thing, same thing, same thing, just lots of it. Like this here, that's one part, that's another, there, and there. So think of it this way. These are few things stacked on top of each other, but they're always the same things repeating. They're not that different. And once you start playing with these nodes and stacking them and making multiple things and making basic shapes that you already know how to do in other software, just replicate them in here and you'll start getting the hang of it. Now, let's model one more object before we move on to more complex tasks. We'll go with this top window frame thing. It's literally a few boxes stacked on top of each other, and there's a bevel here, and we have lots of smaller boxes right there. And if we do that in Houdini, just put down those boxes and subdivide them, merge them all together. We could export them to ZBrush and then add the edge damage on it and use it either as a high poly and bake it down on a lower version of it, or if you're using nanite in engine, it doesn't really matter, the polygon doesn't matter as much, so we could just poly reduce the poly count just a little bit, and then we could export as long as it's UV'd and everything is fine. Okay, let's go into Houdini. I'm gonna move this on the side, put it there, Shift O. Just forget about it for now. We don't need 3 of these. I'm gonna delete those down there. Yeah, so we've got our window, and now I need to do that top frame thing. Let's pull up PureRef. It's always good to look at the reference as you're modeling anything. So I need a few boxes. Let's put down a box. And scale that down there. Okay, just so I could see the window at the same time, I'm gonna put down a transform. Put that here. Hit W. And I'm gonna move the window down just so I could see it as I model it. I'm gonna move it just a little bit more. Yeah. So this display flag will stay there as I model the top frame. So I need another one. Let's merge them and control that. And one more. Yeah, something like that. Now I need those smaller boxes. Oh, forgot about that. You probably need to see the buttons. Okay, I'm gonna move it to one of the sides and then copy and transform. So you, instead of typing copy, what you could do is type the first letter of each word. So CAT, copy and transform. And I'm gonna move it to that side a bit more. Yeah, something like that. Oh, it's up here, not down there. Yeah, let's move it. And that's the nice thing about modeling procedurally. You could just as easily go back and change things. That one needs to go back a bit. There. This is a bit higher. Cool. There is a bevel here, and there is a smaller. Okay, we need another one of these. So for that big one up here, it needs to be beveled first. There. So let's put down a bevel. Select the edge, so hit 3 for edges. Enter, and the distance. Add some edge loops. There. Got our frame. Now what we could do is add some extra edge loops and bevels and that kind of thing, and export that into ZBrush and add the edge detail. So let's do bevel first. I'll show you what would happen if we do subdivide immediately. I think if you know anything about modeling, you would probably, expect this result. So before we even do that, we need some supporting edge loops. So a bevel is good enough for that. That's enough. And then you put the subdivide. Let's do some more. I'm increasing the edge loops on the bevel. That's why the subdivide is nicer now. And I'll subdivide even more. I can still see some faceting here, and this would be problematic in ZBrush. It's really annoying trying to smooth this out. So all I can do is just go back to the poly bevel, this previous one that we beveled here, and add extra edge loops here. And with that, I would get rid of this. Okay, it seems like this bevel maybe needs to change a bit. Let's try. Okay. Yeah, I think this is smoother. These parts are not nice, of course, but it's not a problem for ZBrush. This is just one edge. You could just trim dynamic really quickly. And with some smoothing, some more subdivisions in ZBrush, this should be fine as well. Cool. Of course, if this is not good enough as well, you could always add supporting edge loops, such as with a clip. Do this. Yeah, the bevel clip, and then so right now it's on the x-axis, so let's put it on and zero that out. Put all primitives and move it. And another one on the other side. This would give a better result when subdividing. So let's visualize it. I'm gonna plug it in. Now we got rid of this extra faceting. I'm gonna bypass them to see the result. See how it's just a little bit nicer with those extra edge loops on the sides. Cool. Now we're ready for ZBrush. I'll take all of that, just put it down here, Shift O. That's my object, my thing I just modeled, and I'll export first. This is just a preference. You don't have to do this, but window top. This is how I like to do things. So later on I could Control F and look for it, window, and I can go to it immediately and see it. So now I can hit File, of course, bypass, put it in, pick the place, and export. Once it's out, I can go to ZBrush and add all the extra detail. Now this is not a ZBrush tutorial, so I'm gonna just import the final result. I brought in the ZBrush asset, transformed it down here. Now we could do a few things from here, depending on what type of project you're making. You either wanna lower the resolution and bake it, or you could export as is if you want to use the nanite. But even if you want to use nanite, you would still need to reduce it a bit. It still holds up, even with the lower. So right now this is at, if you click on the I button, there's 21,000, but before it was 200,000. So we lowered it quite a bit. 21,000 is good enough for nanite if you're using nanite. But if you want to optimize it, you could bake it, use Maps Baker, Could either bake it in Houdini, or of course, if you prefer Marmoset, you could go with that. Of course, after you have some UVs, you need some UVs to do that. Let's say I'm happy with this for now. You could plug that in here and the high poly in there and bake that. Pick the normal and bake it somewhere, and that'll give you the textures. Or you could optimize it in a way that it's not, right now it's triangulated. If you need a better topology like quads and that kind of thing, you might have to do that manually. So a topo build would be perfect for that. You plug that in there. Just highlight that for a second and start doing this kind of thing, on and on. And you have a few options up there, shift 2, 3 for extra edge loops. And that's the manual retopology you're used to in other 3D modeling packages. You could totally do that in here with a topo build, and it'll store all of your points manually. And you could push it really far. I did that in one of my earlier projects. So I got this from ZBrush, and I went in and did the manual topology with the topo build, and I used a lot of topo builds. You could see them, they're all in red down here. And yeah, so I added a few layers, and the blue part is just Houdini generated stuff. I think the red part is the wires and that kind of thing. But yeah, you could add lots of topo builds and use those to clean up your geometry if you need to. Most of the assets are fine. This is fine as is. You just put down a normal, soften some normals, and you call it done, because this is a static asset. It's not gonna move. You don't really need to work on the topology as much. But if you have a character, you probably need to sit there and do topo builds and clean it up. And the next tutorial will dive more deeply into how can we process high poly assets, something that would be from ZBrush or a Megascan or something like that. We could shape it in a way that it's game friendly. Let's see how we can get an asset like this stairs from ZBrush or Megascans and UV it, optimize it so it's ready for Unreal Engine. I've already done this once, but I'll do it again. I'm gonna delete these. This is our file. Let's put down this file node, and bring in the stairs. This should be available to download as well. So as you can see, it's really dense and there's no UVs. So let's begin by doing it the dirty way, UV. So if you click UV, type in UV, and you'll get all the UVing options. I'm gonna use UV unwrap first. It's pretty fast, but it doesn't give the exact result you want. And that's the nature of any automatic tool. I'm gonna UV layout now. They're really sparse. We need to take the whole space. And UV visualize. In Houdini 19 and upward, you'll probably see UV option here, but for now we'll look at it this way. And if you click on the visualize seams, it's gonna create a polywire. This is an actual tube. It might take some time if your asset is a bit dense. We don't really need it because we'll use the visualize islands. With the color difference in color, you'll know where the seams are. So right now, if I'm looking at this asset from this side, from this angle, I'll probably see a cut here and here, here and there. And it's not that desirable. Same from the other side. 1, 2, 3, 4. And these would be visible if you're trying to tile a texture. If you're texturing the stairs manually, if you're going and baking some textures on it, this wouldn't be a big problem because a substance painter would tile the smart materials. It's a smart way to texture in substance, but the problem is you would have to do this for every single asset, and then if you did that, you would have a unique texture for every single asset, and that might not be the most optimal thing. So instead, what you would do is you would try to reuse tileable textures everywhere and just reuse them on this asset, the other asset, and the other. And this way, you wouldn't have to have so many textures. So if you want to use a tileable texture, you need to get rid of as many seams as possible. So in this case, we need to hide these seams somewhere else. Maybe somewhere down here, underneath this one, and there. And we'll keep the side ones because, as you could see, you cannot see the side ones. It doesn't matter. But for here, this would be a problem if we had a seam here and there. So let's try to select the seams and cut them. And the nice thing about this Z remeshed asset from ZBrush, it has this nice topology. It's not perfect, of course, but it's good enough to select the seams. And then we can poly reduce. So let's begin by adding a group. We'll put all our seams in a group, and it'll be an edge group where we're trying to select edges. And we'll hit that, and we'll start by doing this one and hit A, hold, then shift to select it. Shift A, and so on, all the way around. And when you're done, you hit enter. And now we have that seam. I've already done this once. I'm gonna bring that group in here. We'll just name it seams. So the name of the node is up here. Which is group 1. And the name of the group is in blue. We'll connect that. And now I have all my seams selected. You could see I selected the underneath one. Same here. And there. And now this would unwrap nicely if I use a UV flatten. If I plug that in and do it automatically, it's not gonna work. It didn't unwrap anything. These are the 4 steps. There's no seams. So in this, under the seams tab, see if you hover over, it says layout seam group. It needs a group, and this is a group, and it's an edge group. So we could put that in here. seams. And now this should unwrap. We still need to straighten out these curved ones. Afterwards, we'll lay out and reduce the poly count. But before I do that, let me show you why I'm doing it this way. Because if I poly reduce, and go to, let's say, 20, poly reduce would do this triangulated geometry, and it'll be really difficult trying to select the seams with edge loops. You could still do it, but it's annoying, as you can see. One nice feature about poly reduce, it retains the UVs. So if we wanna, for example, go back to this one we already made and reduce it afterwards, the UVs would remain and they'll be reduced. See, the outer edges are maintained, but the inner, they just get demolished, as you could see here. And we'll put that in there, see how it visualizes the UVs. And it still holds up. Let's continue with the UV flatten. We need to straighten out these. We'll first switch this to angle based, and this might automatically do it. This is good enough for me, but I could always go in and do these manually. There should be a link attached to this video somewhere where you can learn more about the UV flatten. Let's just poly reduce and UV layout and call it done. I'm gonna copy that one, copy the UV layout. I need some more padding. Be careful with the spread to all available space. This sometimes crashes for some reason. Let's do by island 3D and scale to match. Cool. Let's visualize this and see the difference. See how each one of these is its own island, but at the same time the seams are where they're supposed to be. They're on the inside where you don't see them, whereas this one, they're just everywhere. Pretty neat difference. So this is the fast and easy way if you don't really care about how your asset looks, and this is a manual way where you could get the exact result you want. If you want to use multiple UVs, like I did in my case, I used another UV set to sample the paint texture, this pattern. We could attribute copy, and we'll copy the same UV set. So if we go to 5 and we'll look at that, go to the UV vertex, you can only see UV right now, but the other UV set would show up underneath it if we have another one. So let's copy the one we have. So the UVs, they are vertex, they're vertices, whereas these here are points. So we have points and we have vertices. See how each point it's split into 4 vertices, and that's how we can unwrap things in the UV space. I will get more into that later. But for now, let's copy. So instead of points, we need vertices to work with the UVs. Delete CD. CD is the color. So we're not trying to copy color. We want to copy UV. And we'll name it UV1. If we look, we have now another UV set. It's the exact same. I just switched it, but there's no difference. We can do a UV transform. And right now we'll transform the UV, and we can transform UV1, but let's do on UV. And let's try to move it. Okay, it's on this side. If I go to the UV1, it's there. So now we can have multiple UVs, and each UV can be in a different location on the 0 to 1 space. And we can sample multiple textures in different ways and have more variety with the shaders we build in Unreal. You could also use UV edit if you want some control. Press S to go into selection mode, double click, then T to move. And you can hit Y to toggle between. Let's say I'm happy with this. I'll hit enter or escape to go out of this tool. And now we just transformed UV. We're on UV. Go to UV1. There is nothing. Go back to UV. If I put this UV1, now it happened on UV1, not UV. See? So this is the attribute that would specify which UV set we're controlling. And that's how you switch between the UV sets. And of course, we can keep doing more things like UV flatten. Preserve the seams, so we wouldn't change what happened earlier. Nice, it made it even straighter. I guess if we use spectral after the angle base, it'll just straighten things out automatically. That's nice. Okay, let's say I want even more seams in here. I can double click. Well, now it's poly reduced, so it's kind of annoying trying to select things. Let's say I'm happy with this. There, it got it. Now we have another UV island. And there it is. That's the extra UV island. Let's put this whole thing in a box. That too. Lastly, I want to add this paint. So I've got the texture and I need to tile it just on the front and the back over there. I'm gonna poly reduce even more. Put down a material node. and find the texture. Go here, hit D, you get more options, and we'll go to background under this, and now it sits in the background. I can change the brightness. This is enough. I'll move these and place them wherever I want them now. So with a UV edit, before, keep the material last. Visualize the material and move this at the same time. Let's split the viewport. Select the UV edit, hit enter, S and T. Move this, so where is it? There. So now I can say which part I want. Let's say this one, and I'll scale it up. And the parts I don't need, I can easily just scale down all the way down, so they don't sample any detail. And in Engine, we can layer this in a second UV set. So if we go to the material, you can see I'm using coordinate 1, UV coordinate 1, and that is plugged into the texture, the paint pattern. Whereas the rest of the tileable textures, they have coordinate 0. So these stripes there would sample the pattern, the paint pattern, but the whole stairs would take regular tileable textures such as this. So I've gone ahead and did that in my other file, and the stairs can be used upside down as well. Cool. Let's put these away for now and move on to the next thing. Let's look at trim sheets. There's a few built-in tools for trim sheets. If you type in trim, there's these 3. So this is a utility which goes in here, and that's the geometry you want to trim sheet. Same with this one, that's the geometry you want to trim sheet, and the utility goes on that side. So you could use whichever. This would decide automatically how it's gonna trim, but this you have manual control. You can select which ones you want to trim. So let's use this on the window we made. I'm gonna turn off the color for now and put that in here. Now we need something in the utility. I'm gonna cut this for now, put this on the side, we don't need it. Let's worry about this for now. So the utility needs a grid with some subdivisions depending on how many you need for your trim sheet. So let's look at that. We need to have some UVs first. UV project would be the fastest and easiest for a grid. So let's project on the, see down there, it's like Z and X, Z axis. ZX, then you hit initialize. That goes in here. The trim texture utility needs a texture, of course. And we'll pick that thing, but it's upside down, so let's put 2 here, 6 there. And now you'll need to edit and move these where you want them to be. There. There. Now we can go ahead and start. Select the thing, enter. Now everything is highlighted, but so there we have a problem. We should go back here and hit initialize. Now they're split. See, now we could have the different. If I hit here and go and click one there, it assigned it, but I still can't see anything. We need to put down a material and specify that texture. Now it shows up. Go back here, hit enter, and select another. Let's put it here. No, I want that one. Put it there. So it's just click and click, and you have the instructions down there. So after you put down click, click, now you can start scaling things, but you need to switch this to scale, or you could horizontal or vertical. So I think I want some vertical here. I like that. Now let's say this down here, scale up, right click, horizontal, scale this way, there, scale, vertical, and so on. You could go ahead and texture this whole thing this way. And let's look at the automatic one for a second. Let's just put it in, see what spits out. Cool, let's put this in a box, Shift O, and call it trim sheet. A trim sheet would extend beyond the boundary of the 0 to 1 space, but there's another way, an easy way to set what quadrants do you need if you're trying to fit them exactly inside the 0, 1 space. Let's use a layout, UV layout. And I'm gonna copy this part, the grid with the guts on it, because I'll use each one of these as a boundary, and that boundary goes into the second, the target geometry. And I'll UV the same thing. Let's say I'll put that in here, the window, and we'll look at the option here, pack info, switch it to island from second input, and now something changed. We can use this group and switch it to whichever primitive number, so 0, 1, 2, 3, 4. Here, this is 4. And this is a group. So right now I didn't specify any group here, So it's just taking the primitive number of the whole, this whole primitive or face. But you could also specify a group. And let's say this is my group. And I'm just gonna call it something. UV target. Put that in here. And I can type that in here. And it'll always be in the UV target space. So this would be really useful if you're trying to UV automatically in a procedural way, where you could model your stuff and give them the UV target group, and in the end when you hit UV layout, each part knows where to go based on the group. Let's put these in the box first. That too. And let's look at some cool tools. First, put down a box. And let's check out the box cutter. When you hit enter, you see the instructions down there. Control, drag, release, hit A. Again, control, drag, release, hit A, and so on. There's subtract and there's also union, so you can add as well. You need to hit A to commit the change. Another cool tool, there's the snow buildup. Let's change some parameters. Highlight to reduce the amount of... Now this says snow, but it could be used as moss or grass, you know, anything that hangs on other stuff. And you could change that, put some nice shader on it and engine, make it look really nice. And you could always go back, do another subtraction, hit enter, A, then see the change. Nice. Let's look at the edge damage. I'm gonna place that before. I don't need any damage on the snow. I just need to damage the hard edges here. Now it just smoothed everything, but I'm gonna switch it to Boolean up here. Yeah, this is more like it. Let's look at the cable tool. The cable generator requires a curve, so let's put down one. keep playing with the parameters of the cable generator. You could turn on the color to see that. Let's look at the tree generator. We have a few tools. What we need is the controller, the trunk generator, and the branch generator. Plug that into the second input. This will act as a controller, like top down, and whatever we change here, everything will change down there. I'm gonna put down a branch generator and a leaf generator. That and that. And play with the parameters to get the look you're going for. This is one weird tree. Put down a simple leaf, plug that in here. I need some more branches. Let's branch. Even more. Let's add some more leaves. Even more. Yeah, that's too much. Keep it there. And another. I see it's already struggling, so I don't want to plug that in here. Add all those extra leaves on top. So you could keep playing with the parameters of all of these things as long as they're plugged into the correct order, and you'll end up with something nicer than this, hopefully. And in my case, that was the result, an engine. There is one more tool I need to show you, but it's a bit complex. We'll keep it for another time, but I need to show you what this tool can do. So this is it, the building generator. It takes a few boxes and a few modules. These are all the modules, and it'll place them where they're supposed to be. And you'll have a city in no time. So what happens is you have this window, you model this, and you give it a utility. This is one of the building generator utilities. It defines the dimensions and the name of it. You merge everything, all of them in, and all the other ones over here, and they all go into the same node, the second input. And this is one of those boxes, probably this one. And what happens is, see this orange thing? This is a loop. It's looping over this box and this box and that box, that box, that box, over and over again until it goes through them all, and it replaces the box with these modules for all of them. That's the idea. And we'll get more into that, and we'll talk about for loops and some more technical stuff in the upcoming videos. And if you want to download this file and play with it, I have it on my Gumroad. You could just open that file and learn from it. And here it is in Engine. So what I did, basically, I just used the vertex color of each of the buildings from Houdini into Unreal, and that's how I textured most of this stuff as quickly as possible. Let's make some rocks. First, I'm gonna put these away. Shift O. I'll put them down here. And let's put down a sphere. So the idea is add lots of geometry on this sphere and reshape it in a way that it would have rock-like detail. First, we'll change this from primitive to polygon. Increase the subdivisions way more. Let's use a mountain. I'm gonna change its size. I'll clip the bottom and polyfill. Okay, now that it is watertight, we can use something called VDB. So VDB is voxels. We'll first have to convert the geometry into VDB and then do some voxel-y stuff, then convert back to geometry. So first we need VDB from polygons. There. Now the voxels, they're too big, so I'm gonna lower this a bit. Be careful with this number. If it's too low, you might end up crashing your PC. I'm gonna go even lower. No, actually 1 is enough. I don't want to see the faceting. I could always subdivide before it to get rid of the faceting. So let's do that. And look at it now. We'll subdivide even more. So now it's nice and round. Let's do some operations here and then we'll convert VDB in the end. And we'll put that to polygons. So now we're back to polygons. But we have this space in here. Now we're working with voxels. So let's do a VDB reshape. So it's set to dilate, but we'll need erode. Erode will give a nice result, especially when you're making rocks. Because usually rocks over time, what happens is they start decaying and they would lose some of their mass and end up with these sharp edges. So erode would be a good idea in this case. Okay, I feel like this is good enough. And now we'll switch back to geometry. Now you could either call this done and reduce. Go to 20. Or we can go even further and add another mountain. This is too much, so we'll lower this to 0.01, let's say 5. even more, 1. Okay, lower this. Cool. Now this could be a bigger rock, something like a mountain. And you could always keep adding more subdivisions, so let's add 1 before it. Now you have so much detail on there. And depending on what you want, you could either be happy with this or that. And the best thing, we can always go back and change the size of it. That's too much. 2 over there. Okay, let's look at this. Cool. Let's get more creative. Let's add another input other than a sphere. Let's add a box and merge them. This box needs some subdivisions. It's not showing up. When it's being subdivided down here, it just goes away. So let's do some subdivisions here, but we'll put it to the last one so it retains the shape. Just another time, and we'll look at it now. Let's draw some polywires. Put down some curves. Go to the side view. Plug that in here. Plug that there. Before we do that, let's just look at the input. And start drawing. Add more divisions, and let's resample before that. Resample, it's like subdivisions, but it's good for curves. Let's do something like that and see what the result would end up. Cool. Let's add another curve. Control middle mouse to get rid of that detail. Merge them, put that in here. And I'm gonna look at it here before I add all this detail, because this would have to recompile every time I make another change. So let's just look here while everything is still at a low poly stage. Add some more curves. So hit there, and let's do this here, like that. Escape, and let's see the result. So the erode just destroyed it. Let's increase the radius. So what's happening here? Subdivide. Yeah, this. When I switch to, see, that's the problem. We didn't close this gap because the polyfill, it's complaining. They have odd number of edges, so let's just use triangles instead. That would be easier. That is some archway mountainous shape. Wait a second, I got an idea. Match size, puts it down on the 0 axis, but I need it, yeah, there. You may be wondering what I'm doing, but just wait for it. Let's move this atrocity to the side and look at how can we take a low poly and turn it into a high poly. So I'll put down a box. The quick and easy way is subdivide. And the problem with subdivisions, you need the edge loops. So a bevel would do here. Increase the edge loops. Now it's set to round. If we put it at crease, this would give a better result with the subdivide. And this goes with any other type of geometry. Some assets are difficult to bevel or crease, so the subdivision method doesn't work as well. Let's try the box cutter we made earlier. this one. I'll put down an object merge and drag it, put it in the object one. So this is the teleportation thing we talked about at the beginning of the tutorial series. So that's the crease and the subdivide. There's a problem here. The crease is going overboard, so we need to lower that down, and still doesn't work. So this probably is not the best idea for this type of geometry, but it works on a simpler, well-constructed geometry. Another way is by using the VDB. This is why we went through it earlier with the rock generation thing. So let's convert. First, we need to VDB from polygons. Lower the voxel size. Then convert. So this is almost like Dynamesh in a way. Put it to polygons. We can keep lowering that, 0.5, and now everything is connected. And finally, you could poly reduce. And in between here, you could either VDB smooth. I prefer to use the SDF one. Or you could VDB reshape. And the reshape, you have few options, either dilate, erode, open, or close. Open or close, it's a combination of dilate and erode. So dilate would go, it would extend beyond. Erode would subtract in. You either use the subdivision Catmull-Clark technique or the VDB and finally poly reduce. Now there is pros and cons to both. One, the topology, you lose the original topology, and the other, it doesn't work in all cases, especially when you have dirty geometry. This is not even connected. These are more than four-sided polygons. This can be solved with VDB, and if you have clean geometry, you could easily crease and hit subdivide. So there are two types of decals. There's the projected decal, which I'm using right here in Engine, and the other type is the mesh decal, which comes in with the asset itself. So it's actual geometry that sits really close to the asset, and it's exported with the asset. So we'll look at how can we place these decals automatically or more easily. So I'll put down a grid first to place the decal on. project, UV project, and initialize. This would immediately give us that. I'm gonna do the opposite here and bring in the material. Put the texture just so I could see it. First off, I prefer the light background, and second, you might want to turn this back to the checkerboard. So if you type that in, $HH, pick UV grid, .pick. We need one more subdivision there, and another one here. Now we'll enumerate the numbers of, oh wait, this is flipped. There. Enumerate. So we number them. Name this decal underscore index. This is the attribute that the decal would take. Decal projector. So this would go here. That there. We'll scatter some points. Plug that in the second input. Place, update. So this is too big. Let's lower the size. Initialize again. I'm gonna transform it here. Okay, and they're not taking the orientation of the surface. So we'll need a normal on the box and put that to points. Now it points out this way. One last problem is that this is rotated. There. Now we can start switching with each one. So this would place it randomly, but instead of random, here you could provide the points and in the end give it the index. And you could always go in and change the scale and rotate for each of them. Say I had a clip here. I can group. The points I need. Hit blast here. Group 4, everything except group 4. Then maybe edit. If you want extra controls. Let's do some automatic poly painting. I'll use this asset. You could use any asset with lots of geometry. First, I'll calculate the occlusion and then the curvature. Finally, the slope. that's the occlusion. Curvature, you get the convexity and concavity, both of them, green and red. And the slope, I'm just gonna flip it. Cool. Now I'm gonna put down a wrangle and plug all of these in. This node, you can type code in it here. It's called Vex. And for now, just copy and paste the code I provided. And later on, we'll learn more about this. Hit that button to get all the parameters and put them all to 1. That 2, 1, 1, everything to 1. Okay, maybe increase that some more. So the first one is for the AO power. The tints are down there, the color tint. And as you can see, we can isolate these colors. Currently, these colors are located on the points. These are not textures, they're like poly paint. So this white, instead of this white, it will be this blue-ish or green or whatever. Cool. And we can always go in and paint manually. Like that. Pick a color and start painting. But you know, if you're gonna use Houdini, you're probably gonna be automating most of that stuff. But in the end, if you need to do some last minute changes, something like, oh, I need this part to be red, so I'll just color this part red. You could do that. This looks horrible, but play with the parameters and you can get it to look way nicer than this. And don't worry about this, we'll get into it bit by bit. And hopefully you wouldn't be scared of just typing letters and numbers. We'll take it one step at a time. Okay, let's move on to the next thing. Let's make some cloth. I put down a grid with some subdivisions. Now look for vellum. Vellum is the Houdini cloth, hair, and grain thing. So let's initialize a cloth, and you could change it here. So these different nodes are all here. First input the geometry, second constraint, and the last is the collision. Oh, there. If you don't want the nodes to update, you could change it to manual. So if you do any changes now, nothing would update, but keep it on auto update. Let's use the brush first. That is intuitive. Hit enter and start brushing, painting on the cloth, and it should just simulate accordingly. Now you have some options here. 2 will drag everything, but 1 is a brush. It'll smoothly or softly. 3, so Control Shift and mouse to change the size, and if you click 3, now everything will go to the center, or to the point you're. 4 will swirl everything, so it's folding on itself. 4 and 5. So you've got some options here. Mainly the number 2 is for the brush. That's what you would probably be using. And there's more options up there. You could hit G to simulate it. Now it's falling down. And as you're simulating it, it could go to 2 and bring everything up. And hit G again to stop it. Now I can go back to 1 and start brushing again. Now there's no UVs, but we could add some UV. So with some UV unwrapping, let's see, it doesn't update. So you have to UV first before you go in and use the brush. I'm gonna swirl it a bit. Number 4, 5 to soften a bit. 4, 5. Cool. And 2 with G, 2 to go up. There, and G. 4, 5, and soften a bit here. Cool. This could be something that hangs on a ledge or something. And finally, we can use a solver, a vellum solver. Plug that in. So this would simulate it. If you hit the play bar down there, it will fall down. But right now it's gonna go through unless you hit the ground position, that button there. But you could also add another type of geometry. So it can be, I don't know, the pig head. And that could be going there. I'm gonna move it a bit. There. Backwards a bit. And simulate again. Wait, no. I need some more scale. Yeah, now. Stop it here. I don't like the ground. Do it again. Stop. Cool. Let's try the vellum brush again after. So it's not going to work. What we would have to do is somehow freeze this. Let's put down a time shift. Time shift would stop time at a particular point, so I want to stop it at 41. So right now it's $F. $F is the frame, but I don't want it to switch with the frame. I want it to be 41. So I'll delete the channels, or you could Control Shift left click, and now it's 41. Now it's gonna stay there. I usually put these to green. Anything that changes time, I put it to green. So let's try that there. Can I paint on that? Yes, I can. So it just had a problem with the time dependency. We just needed to freeze time. Now we can brush again. So as you can see, we can turn geometry into cloth, then do some brushing here and there, simulate it, and freeze time, then brush again over and over, and we can keep repeating, but be careful with how many things you keep adding, stacking on top of each other. If you need to recompile the whole network, it might get slower. So that's why it's easier to stop the geometry in its current position and then work on it again. So another way would be is by using a null. Null doesn't do anything, but you could freeze it. So if I put that in here and freeze it, now I can detach this, and it's baked into the file itself. So this would increase the size of your file. Memory, see, it's that big. And this would bypass all of that stuff because you have it now. But you cannot go back and do any changes because it's stuck in this position, and if I remove this, it goes away. So be careful with that. You could always use a file and plug that in here and go to write, export it, then use another file and read. So you need to go back to read and find this file that you exported, you import it again and keep working on it. This way you wouldn't have to go through the network every time you want to make a change. Cool. And one last thing that's really neat with Vellum, there's a Vellum post process. And this will add some extra detail at the end. So you could do some subdivision. And that is way nicer now. There's some detangle. If things were stuck on top of each other. Yeah. It'll inflate. And you can give it some thickness. Let's look at the UVs. They're still good. There's something weird there, but let's put down a UV visualize and see the UVs. Oh, I see. This line right here is the extruded part right there in between both the top and the bottom. And you could always change this, the forces and wind. So there's a ton of parameters in here you can play with. So take your time and make something cool with some vellum cloth. And there is more than just cloth. There is other stuff in here. Let's make some terrains. In Houdini, they're called height fields. So a height field, it's sort of like geometry, but not really. It's like top-down thing. You can only go up and down. So it's really optimized and could be used to make terrains. I'm gonna lower the subdivisions a bit. So since this is gonna be used as textures, we'll use the 512 or 1024, that kind of thing. So we'll keep these as if they're pixels. And then let's do some height field noise. So we have some noise now. Let's use the height field erode, and that's a really nice node. This usually takes about 25 seconds for 512. Cool. There's a lot of options here. You could keep playing with them and hit simulate again and again. I'm gonna turn off the visualization for now. Nice. Then let's do a distort. HF distort by noise. Lower that, increase that. See what the distort does. Cool. I need to flatten out some areas here to make a road or some place so players can walk on. Right now it's too jagged. First we'll mask by feature, height field, mask by feature, and we'll mask by slope. But I'll invert it just to get the red parts down there. Yeah, and now I'll use a slump, HF slump. Okay. Now I'll clear the mask just so I could see what I'm doing. See the difference? It's better for gameplay if you have a flatter area. Let's say you want to add a building, but this area is too steep to add a building on top, so maybe you need to flatten this area out here. What we could do is we could add a box. And project that box onto that area. So HF project, put that here, that there, and now it's part of the height field. Now you can bake it in a height map as well, but it's just too sharp right now, so I'm gonna bevel it before. Increase the bevel distance even more, add some subdivisions even more, like that. Okay, so you get the idea. You could always keep adding those objects on top. You could even scatter objects and place them just randomly, or by a mask. Now that I look at it, I'd rather have this before the distort up there. This looks a little bit more decent. I feel like we need some more resolution, so we could use HF free sample. It's nicer now. Let's try that. Okay. Add another HF noise. I'm just trying to blend this in. This noise is too much. there, something like that. Okay, let's say you want a road just here, maybe even going up the mountain. So what we could do is put down a curve and then mask by object, take that mask and use a slump to flatten that area. So let's put down a curve. I'm gonna put it on polygon, keep it on freehand. So as we look at the curve, I'll go to the top. So I don't know which the top is. Anyways, visualize that, use this, hit enter, and let's draw a curve randomly here. Okay, and now hit escape. Oh, this is, yeah, like that. Now let's ray. So we'll use this and, oh, there, and the collision is there. Now it's kind of trying to do it, but let's try to minimum distance. Did that do it? Yeah. Cool. Let's resample this curve. I'm noticing that things are getting slower. It's probably the resample. It's too much. So let's put it on 3 for now. Yeah, this is much faster. Watch out for the voxels down there. Okay, resample. Gonna put it to subdivide. See the resolution on it. Okay, so the idea is we'll take this curve and turn it into a polywire. And increase that. We'll mask by object. Height field mask object. Put that there, that there. Cool. Now we can maybe blur it first. Mask blur. And then I'll use the slump. I'll increase that even more. Okay, let's clear the mask. We had one here. Yeah, I'm just gonna copy it. Put it down there. And now before and after. So now you can go ahead and take your player, go up this mountain and explore, because it's much flatter. It's easier for a player to climb that than over there. That's almost impossible, especially here. Okay, so with a curve you could manually put down the road you want it to go. And before we end this, you'll probably need to scatter some stuff, maybe trees or something like that. Before I clear the mask, I'll use this mask to scatter things everywhere except on the road. So let's do an HF scatter. And I'll lower this coverage 0.1. Still too much. 0.05. Okay, we'll go with this. But there are some points on the mask that I don't like. I don't want them on the mask. So let's try to put that in here. But now the problem is that they're being situated on the mask. I wanted them to go everywhere except on the mask. So let's put down an HF wrangle and type one little tiny code, which is @mask. So the mask itself, it's gonna be inverted. So 1 minus the mask and semicolon to end. So we inverted the mask. Now this scatter would put that new mask in here, and now it's scattered everywhere except on the mask. Cool. Let's CTP, copy to points, and I'll just copy a tube, put the tube in, the points in. The tube is still too small. I'm gonna increase its scale and height. 7-ish. Okay. Let's look at them both together. End caps. Cool. 12. And you could always do things like randomizing the color of each of the scatter points, and you can do attribute randomize. If you keep feeling it's a bit slow, you can always go back all the way up and freeze this, because this, when the whole thing is recompiling, this requires a simulation, so sometimes it might slow down the other stuff. So it's good if you just freeze it, but this would increase your file size. So before I finish up, I'm just gonna randomize the color. And as you can see, now this part, because it doesn't have any color, it went black, and now this yellow exclamation mark, it's looking for some mismatched attributes, because this side has some attributes that this side doesn't have, and otherwise. So this side has color, but this side doesn't. So we'll add color here. Welcome to Candyland. All right, so now how would you even export this thing? Well, you could either use HF output and take this thing and export as height field. I'm just gonna RGB here, save it somewhere. I'll put it there, put that to height. Maybe I'll take the sediment and some water. Hit save to disk, and let's see the result. That's the result. Or you could, if you want, HF convert, and you can turn this into actual geometry. Let's make some clouds. I'm gonna put down a sphere, and I'll turn this into a polygon, increase the subdivisions, and I'll edit. So edit will, we could change things manually like that, but for this task, I'm gonna use sculpt. So yeah, just left click to increase the size of it, and middle mouse to go in. You could see down there it says that. Maybe I'll subdivide once. Then clip. And polyfill. If it didn't work, switch it to triangles. Now I'm gonna just add the cloud as is. So we've got 3 things here. I'll use cloud. It's fully white. There's no shading on it, but you could see the shading if you added lights. I'm gonna go up a level and add a light. It's down there. Let's move it up. Yeah, okay, that's good enough. Let's go in and I'm gonna increase the resolution a bit. Add a cloud noise. Maybe change the element size. Yeah, and the amplitude. That's too much. This is enough. So I can also change the offset. Let's do that. If I put $F in here, this would change with the timeline. So I can animate the noise moving. If I click once on that, I'll see the value of it, and you could see how every time I change the timeline, that number changes. But right now it's too fast, so I'm gonna multiply this by a small number, 0.1. Now I have some cool clouds. There's a few ways to export this outside Houdini. We could either try and bake this into a texture or turn it into geometry every frame. One last problem though, at the end, if I hit play, it snaps back, it doesn't loop. So we'll just use a make loop. And this would literally just loop it. Right. So if you want to switch it to geometry, you could convert VDB first and then keep that to volume, and afterwards convert volume. Now it's geometry. Yeah, so this number here, detail level, we could do 2, let's say, yeah, 2. And now this looks sort of like a terrain, but yeah. So do whatever you want. If you want to go with geometry or texture form, we'll need to use another context. Right now, all we've been doing, we've been working in the geometry, but we need to go somewhere else to export things as a texture. So if we put down an output first, and then hit N, and we get this wheel. I'll go to Vops, hit tab, and we'll look for texture sheet, labs texture sheet. So this needs camera 1 and the node, so Geo1, and object, this is Geo1. It's taking the output of Geo1, and the output is this. I put it here. So render. So we need one more thing, the camera 1. Go back to objects. I need a camera, but this camera is somewhere else. Let's see what it is. It's here. So I can put it in the viewport, drag and drop it like that, and as long as it's locked here, You can zoom out like that, pick whichever angle you want, maybe that angle, and unlock. Now the camera is looking at it like that. Let's go to Vops. And now I'll test it. So I'll export one frame, put it at 256. Right now it's taking the camera resolution. So I'll go to objects, change the view. I want this at 1024. Let's see how it looks. Control B. So that's the render. Control B. Unlock this so I can see it. Okay, and go here, and now we can hit render. And that's the first frame. You could see the light, it's just shining in too bright. It's right there. So you could move this out of the way, and if you want to increase the resolution you could, and put this to 64 and hit render, and it's gonna export frame by frame. If you want to compile all that and use it as a flipbook, you could do that. Some other cool techniques that people usually use is they usually put 3 lights and put them to RGB lights. So this would be red, and by rendering this cloud with 3 different lights, in Engine, in the shader, you could extract each of these 3 colors as a mask and color them differently inside the shader. I think this is more than enough about clouds. Let's move on. Let's make an ivy generator. I'm gonna assume this thing is a rock. I'll take this geometry, use it as a rock. First, I just need to turn off these lights and disable them, go back in, and I can still see the lights in here, so I'll turn them off. And you could always hide other objects, so whenever you're inside here, nothing outside would show, especially in other geometry nodes. Cool. So I'll select a few points, and what will happen is we'll try to find a way around, like draw a curve automatically that spreads around this thing, and these would be the roots, and then we'll copy some leaves onto these roots. So first we'll select a few points. So the node, it's called shortest path, find shortest path, and it takes a starting point, select one here, enter, and an ending point there, enter, and it draws the curve or the points in between these. It'll go through this geometry, so the more detail on this, the better this line would be. So to give it some more options to rotate and go around, let's divide this. So we'll connect all those points together. So this curve on top can move here like that diagonally. I'll add a divide and put this to, now you can see it's 3. So this curve changed now. It can move there. So before, let's see before and after. It can move diagonally now. This would make it better. Okay, so let's do, before we put this in and start selecting things manually. Let's find a better way of selecting things somewhat randomly, but we have the ability to say how many points we need to select. So I'll put down a random selection, labs random selection. I'll keep it at points. First, I'll do this, delete non-selected, and by count. So I can tell it how many I need. I just need something like maybe 6, just 6 points. And this, instead of deleting everything, I'm gonna group. So I'll make a group, and that group will go in here at the start and the end. So this, I'll do start. Let's call this group start. So from these 6 points we'll start, and we'll do another one and do end here. But right now both of these have the exact same points. So at the end I'm gonna do a random seed. So they're different. Now plug that in here. Plug that in here. Reset and start, end. So let's do, right now it's going from each to any, but we could do from any start to each end. Let's increase the end count. I'll put it to 12, maybe 21. There, I like that. Let's see the cloud rock-ish thing we had, and that. Put this here, that there. Cool. So now this spreads. It finds the shortest path and it moves along this thing. I'll do a resample for a very specific reason. I can go to curve view. So this attribute, this goes along the curve, and it's sort of like a gradient on a curve. Right now it's hidden, but we'll see it now when we use the polywire. Polywire. See how everything is uniform? First, let's add some divisions. And I want it to get smaller at the end, here and there, but stay bigger at the start. So what we could do is use that attribute, this curve view attribute, and any attribute can go in here inside the values, because an attribute is a value. Add and type in curve view, and it exploded. So right now it's too big, so let's do 0.1, multiply that by 0.1. The issue now, it's flipped. I want it bigger here, smaller there. So let's do 1 minus, but multiply everything by a smaller number. Cool. But this is too small. So I'll add a 0.05. Too much? 2.5. I like that. This is good enough. Okay, maybe color that. There. Now let's add some leaves. There's a simple leaf. I'll just add that. And now we'll take this resampled points. I'll resample them again just to get some control over how many I want. maybe this many. So each point is gonna be a leaf. Copy 2 points. Points there. Oh, points here. And merge. Now, the problem is the orientation. We could fix it in a few ways. Let's do polyframe. Okay, this kind of fixes it, but we could do better. I'm gonna lower the count for a second. Okay, so on the polyframe, put the second one to n. N is the normal, and we'll do a wrangle afterwards, and just type this for now. Cross n and the up vector. Okay, I'm just gonna scale this rock for a second because this is killing me. 2, a bit more, 3, yeah, just needed some space. Alright, keep these some more. And we could always change the scale randomly. Let's do that. So per point, we could add a p-scale value, and that would change. So let's do that. At p-scale equal rand add ptnum. So what happened here is the p-scale would tell the copy to points how big each leaf is, and ptnum is the point number, so this point number. So what I did here, I did a random pt number, so the point number, since each number is different, each different number is going to make a different random number, and that different random number is the scale. And that's how we scale each leaf differently. And this, we'll talk about this later. We're getting there. Cool. And now we could always go back, because this is sort of a generator thing. We could go back and maybe I need 8 or 3 and maybe 30. Let's look at them together. Oh, not that one, that. So now if you start making some rocks, you could scatter these roots on top of them. And one nice thing, in a shader you could maybe add a gradient on it, and in Unreal you could play with that gradient and fade it. Just use an opacity mask and fade it or grow it from that gradient. Now that we're getting familiar with Houdini, let's build some more procedural stuff. But first, what does it even mean to be procedural? Is any node structure procedural? Not necessarily. I'll give you an example. So if I put down a box and I do edit, then hit enter, go to points and move it, then do another edit and move that point. Okay, let's say now that's my box, but if I go back and change the divisions or the poly count, things would not work the same way. So this node structure is not procedural. A procedural network works with whatever input. So whatever we do down here needs to work for all possible inputs. This is what it means to be procedural. So how can we build a network as such? Let's build a fence tool and then change the input and see how it reacts, if it still holds up or not. For that, we'll use a curve as the input. I'm gonna go to the top view. Let me just turn this off, hide other objects, and start drawing a curve. So this curve will be the backbone and we'll build things on top of it. I'm gonna convert it to a line. Convert line. Now we have 0, 1, 2, 3, the numbers of the points and the primitives. So each line is a primitive here, and the primitives are also numbered. Before, we only had one primitive. Convert line makes a primitive for each line, and this will be very helpful. If I use a resample, you could see how this holds up. If I bypass this, the edges would start to fade or go in. They'll get affected. But if I resample, if I convert line, then resample, now I have 2 points here, 2 points there, 2 points there. So each one of these is its own line. They're disconnected from each other. With that, I can maintain the whole shape and add extra points in between. The reason I'm adding these points is to copy other objects onto them. So let's copy a tube. The tube goes here, points there. It's too big. Let's change the curve size, or we'll do another curve. So the resample, it's too much. Let's lower. And these, I need end caps, put it to polygon. This is all preference here. See what you like and do whatever you want. I'm just gonna lower this. That's the line with the points. And each tube was copied to these points. They're underneath the grid, so I'm gonna increase the height here to around 0.5. 0.5 because the height is 1. If you go more with the height, this is not gonna work. And I'll put it to 1. Now here's a neat trick. Select this, drag it and drop it here. Relative reference. Now this is 1 and it's the same number as that. So both of them will move together. So if you remember before, when this was 1, this was 0.5. So this should be half that. So I'll multiply by 0.5. Now, doesn't matter what height it is, it's always gonna be sitting at the grid. We might have two on top of each other. I believe we have duplicated these. So let's try to delete. Let's blast one of them and see. Yeah, see how these were selected and we deleted one, but there's another one underneath it. The reason is here there's 2 points on top of each other. When we used convert line, then resampled, we have 2 points on top of each other. So we'll use fuse and let's see the result now. So the fuse will fix that. And we don't need this anymore. For a fence tool, we'll probably need the top. We'll use the same curve, this curve, and we'll move it up like that. But instead of moving it by hand manually, let's move it with the height of the tube. So we'll do the same thing we did here. Remember the select and drag, but this time we need to drag it to another area. So instead I'm just gonna copy it, copy parameter, because I cannot drag it in. Yeah, so just copy, go here and paste relative. Now they'll move together. If I try to move that, this will move with it. See? This would help in the end when we're trying to control this from a user perspective. You only expose one parameter and it will move a bunch of different things together. Let's merge these. And I'm gonna use polywire for now. I'm using the curve before it was fused, so there's a cut here. I'm just gonna move this down. This fixes it. Add some divisions. Cool. Let's check out if this network is procedural or not. I pressed Shift O. Let's test it. So I'm gonna try to move this and it still works. Oh, by the way, hold X to snap to the grid. I'll put another curve. Hit enter, snap to grid. It works. So this network is procedural. With this, we can start changing that top, change the tube, make it a little nicer, even make electric poles in between. It doesn't have to be a fence. It could be a rail, a road, anything that requires a curve. You could build it with this method. Let's push this a little bit further. We'll build some power lines. So with the same technique we did, we'll use the curve and then copy these. But instead of in the ones in between, we'll just need the corner ones. And in between, we'll do this dangling curve and we'll polywire to get the wires. Where do we begin here? We need the input, the curve, convert line, resample. So we don't need the endpoints. We just need that. then we need these that copy to points. So for now, let's just copy these. This, that. With that curve, I need that, the transformation. So they're both, yep. Now let's do this curve. So it sort of applies gravity in a way. I'm gonna increase the height first. So this is currently linked to this one. If I change this here, the height of that, this would update with it, which we don't want that. We want this to update with that. So I'm gonna copy this height and replace it here. Nice. Now, to do a curve, we need extra points in between. Let's resample. Maybe too much. Something like that. Okay. I'm thinking about adding a gradient in between. So we'd have white in the center and black on the corners. And I'll use the white color to push it down. The black color would stay up. Let's use a color, labs color gradient. Let's see it. Okay, so we have something, but right now it's only coloring one part, and if I try to change the gradient, maybe add some black at the ends, maybe even more white here, black there, it's not gonna work. So we need another way to loop over each primitive. With each primitive, we apply this separately, not on all of them at once. And here, where we can use a for loop, let's put down a for each connected piece. Connect this here. This first one will assign an attribute class to all of them. And this is where we loop over. Everything inside here, inside this orange box, is being processed multiple times. So if we look at this one here and then go to single pass and switch between them, see how we're looping over primitives. I'm gonna put it back. Now let's put the gradient inside. See, something changed. I'm gonna switch the axis to X or Z so the gradient would show up. Now that we have the gradient, let's lower the white point. I'm gonna put down a wrangle. With that, we'll take the position. So at P is the position of the point. Subtract from it the color. Semicolon to close. So CD is the color, at P is the position. CD, the color, is being subtracted from the position. So whatever is on the left is what's being changed, and on the right are the values. So position is being changed by negative color. Something happened. We have the white parts moved, but if we look at everything together, they moved in a weird way. They moved on all three axes. They're going down, left, and to the front. So what happened here, at CD is a color, and a color is RGB. It's three values, and they're being subtracted from the position, the XYZ. I don't want to subtract the X, Y, and Z positions. I just want to subtract the Y. I just want them to go down. No X and no Z. So let's do that. So .R, or you could do .X, it's the same thing. So X, Y, Z, and RGB are the same thing. So let's just use XYZ for convenience sake. So color.x, and we have color.y and color.z. I just need this part. I don't need the rest. So I'll put this to 0 and that to 0. If I hit enter, control enter, it's not gonna work. It's gonna give an error. There's some syntax stuff in here that we need to worry about. I need to put a comma in between them because to separate these three values so they can be identified as a vector. And I need to wrap them inside parentheses. Control enter. And it still does not work. There is one more thing we need to do. We need to set this value. Now it works. And I can go back to the gradient and start playing. To reiterate, the color, specifically the .y, which is green, or just one value out of the three values of a vector of a color, is being subtracted from the position. That's how we go down. Now, what if I want to lower it even further? I could always just multiply it here. So times 2. And it goes down even further. Let's put down a polywire. Maybe also a resample. Make it look even nicer with a subdivision. And we could always go back here. Let's combine these two systems. I'll put down a switch. Put this here, that there. And I'll use the same curve. I'll just put a null here. Easier to connect things into instead of connecting here and there every time if I want to change it. Now with this one curve, I can change this and in the end switch it. It can be either a fence or power lines, just like that. You could change the input and you have parameters in here to play with. Let's talk about physics. Say you have a few objects and you want to use gravity so that fall and on the ground scatter, and maybe you want to use them as a tileable texture later on. So let's put down a dot network. This is usually used to make simulations, especially for RBD, which is the explosions when you have objects that fracture and get destroyed. But we'll use it just to use some gravity for now. And I'll put down Tommy. I don't want the textures. Maybe I'll just rotate him a bit. So when he falls down, right? You don't have to plug that in. We could do this instead. I'll show you, this would be easier to reference inside. But let's just go inside for a second. Double click, go inside. And there's nothing right now. We'll need to bring Tommy in here, so we'll need an object, RBD object. It's a sphere now, but we'll try to get him in here. It's the saw path. So if I try to look for him here, it's going to be difficult to find him. I need to go to the letter T and nothing's. So an easier way would be if I name this out underscore Tommy. So if it's capital letter, it'll show up at the start there, Tommy. Accept, we're in. Plug that in here. There's nothing happening right now. That's the blue line is the simulation being processed, but there's nothing. You could click this for real time, but I'll show you what happens if you don't. Right, go up. So instead of referencing this way, we could do another way. We could plug this in the first input and go inside and use an expression. It's up, input, path. So 2 dots to go up, and the input is 0. It's not gonna work because you need a backslash. Middle mouse, you see the full path. It's object, geometry, and then Tommy. So this, I don't need the null anymore. I could just plug it in here, and anything it's plugged in input 0 will show up inside because this is input 0. Whereas before we were manually going up and looking for nodes with that name. Right, now that that's out of the way, Tommy is inside the simulation. We need to use some gravity. I'll put down gravity force. Well, try it now, and nothing's gonna work. We need a solver and RBD. See how he's falling really fast? We could click on that for real time. So we need a ground plane. I'll merge these. Put that here, try it now. And there. We have some physics. Cool. Now I need multiple objects. So I could start doing this box and placing that up here, rotate a bit, do a sphere, go up and maybe just a bit here, scale, and start doing this. Just plug this in here, that there, go inside,
make more RBG objects, and instead of input 0 it would be 1. So now we have the box. Instead of input 1, 2, that's the sphere, and just put this here. Now let's see. Okay, things react to each other. I'm just gonna place this up, the sphere even above. Cool. But I'm not gonna sit here and put one object at a time, and now I'm running out of inputs. We need another way. We'll use, there's an RBD solver. This huge thing would probably do the trick immediately. Yeah, we need a ground plane. Alright, what's happening? Oh, I see. This is primitive. Put it to polygon. And Tommy lost his clothes. Because what's happening is it's taking each separate object. So this is Tommy without the clothes. So each of his clothes, the pants, they're all separate objects, and this is looping through them all. That's why he's naked right now. But in here we were doing, this was the whole object. So I'll show you what would happen if I use this merge inside just the first input. Everything would be the same object. See? But we don't need that. We need them separate, because we're gonna do, I don't know, like a 1,000 object, and we'll simulate them all on top of each other. So this part here was nice, but all we need is this thing. And this, if you go in, I don't see anything here, but it'll just do the job for you. But I needed to show you this first to introduce you to the simulation parts and the DOP and all that kind of stuff. So you would have a collider and objects all in the merge. You need a solver to loop through stuff, and gravity would just do this negative thing on the y-axis, and things would fall each simulation, each part of the timeline. All right, so we'll start doing some, we'll take these, just these two for now. And what I'm gonna do is I'm gonna scatter some points on this sphere. Scatter. That's too many. Right, this is enough. Copy to points. I'll copy the boxes to those points. Right, scale that a bit. Cool, let's try it now. Save first, of course. And nice. Right, so they're all the same. They're the same box. Maybe I need some variation, and here is where the attributes come in handy. That'll be really useful here. So per instance, per point, we'll color each point, and then this copy to point will transfer the color from here to each box. So we could first try color, and we'll see the difference. We'll put the color here and color it orange. All right, now everything's orange. Okay, what if I put it on here and now everything is also orange. There, right. So we need another way of, well, of course, because there's one color. We need a way to randomize or do different types of gradation, or we need a difference. So we'll put down a random attribute randomize. And it's set to CD. I'll delete this, and there. CD is the color, so it's randomizing the color per point. And when we're copying that box to them, we'll see the... So this is the geometry spreadsheet, which we will be talking about in a little bit. And you could see the CD, the color down here. So after the attribute randomize, I could randomize maybe the normal. So this, we'll see what the normal is. That's without the normal, that's with the normal. So it's a direction of the point. So imagine a point sitting in space and looking that way or this way. Yeah. And the box would carry that normal and turn into that direction. If we look at the points normals, there. But when you copy things to them, you don't, because the points are gone, they're boxes instead of them, so there's no normal anymore. Another thing would be scale. So if I do another randomize, there, the scale, the scales would be randomized uniformly, because P scale is for uniform scale. But if we try scale, things would get randomized on all axes. But I'm gonna keep it to P scale for now. And the minimum value is 0. P scale is a, let's see if, yeah. You don't need 3 dimensions for P scale. See the P scale down there in the geometry spreadsheet? Oh, by the way, geometry spreadsheet, there, inspector, and geometry spreadsheet. The minimum value is 0, so I'm just gonna increase it a bit. Yeah, 0.3 is better. Okay, now, for the moment we've been waiting for, RBD. Okay, I'll just leave it there. Go to the top view. I'll put down a null here, just so I don't want to see the white background. All right. Let's tile this. There's a mesh tiler somewhere here. Yeah, we'll do that. And we need a grid for that. So there, we'll see this, right? Maybe lower, smaller, somewhere there. Okay, there. Look at it now. Right, there. I just had this on. Okay. So this is supposed to tile. Let's try it. Can I do another transform next to it? Well, what's the length? It's 5. And maybe another one over the other side, -5. It looks seamless, yeah? So now we just need to bake this down into a texture if you want, or use some, maybe it's too harsh right now, it's the the boxes, you need some VDB or smooth it out, do more stuff, maybe do something more interesting than a box.
Before we go on any further, I have postponed this topic for far too long. I need to talk about a few things to give you a better understanding about how Houdini operates. But before we do anything, let's commence to phase 2. We need to upgrade our desktop. We don't need this parameter tab anymore because we'll open another one with that. Parameters. And down here, we'll add the inspector geometry spreadsheet. This would give us information about our geometry in the scene. This spreadsheet is your eyes. It's really important when you're trying to manipulate geometry and do if statements, for loops, that kind of thing. This would give you information about your points, vertices, primitives, and the detail. So what is all of this? And what are these point numbers, primitive numbers? Why do we even need them? I'll put down an add node first. So we'll create 1 point and 1 point only. This is point 0. And you could turn these on and off, the point to show it. Point number, there's the primitives and the vertices. Right now we only have 1 point and it's point 0. We start the count from 0. 0, 1, 2 and so on. So that we don't have any vertices, no primitives and no detail. Only point 0 with 0, 0, 0, 0 on the X, Y, and Z, because it's 0, 0, 0 here. If I move this to 1, it's 1 on the X, 0 on the Y, 0 on the Z. And you could see it just moved there. I'll put down a line, see the difference in between these two. So a line has 2 points, 0 and 1, and the point 1, it's the Y is 1. It has 2 vertices and the 1 primitive 0. No detail. Okay. Where is the edge? Is the primitive the edge? Because it's 0 and there is 0? No, it's not. Because if we put down a grid, look at that grid. I'm just gonna lower this count. Maybe 4 by 4. We have 0 to 8, but these are the primitives. So 0 to 8, and they are situated on the center. 0 to 8. So are the primitives the faces? Is that it? Or are they the edges? Here's the weird thing about Houdini compared to other 3D software. Primitives, they are the connection between points. They could be edges, they could be faces, but all there is points. I'm gonna turn off the vertices for a second. So we see the points in blue and they're numbered. We go to this tab here and they're numbered from 0 to 15. So we have 16 points and 9 primitives. So the vertices, I'm gonna turn them back on. They are welding the primitives with the points. So 0.5, 6, 9, and 10, they're all connected through primitive 4, and these 4 vertices in between. And we can see that down here. So under vertices, we should see primitive 4.5 as a connection and primitive 4.6 another connection. Primitive 4.9, primitive 4.10. And let's confirm that by doing a group and selecting that. So under primitive, it's primitive 4. Under points, it's 0.5, 6, 9, and 10. 5, 6, 9, and 10. And under vertices, they're written in a weird way. So let's look at it. So primitive is the first thing you see. 4, 4, 4, 4. It's the same primitive for all of the vertices. And under this is the point number. So primitive 4.5, primitive 4.5, primitive 4.6, primitive 4.10 there, and primitive 4.9. So the welding happens this way, from left to this way. I think it's clockwise. And this extra number here, this is the vertex number, 0, 1, 2, 3. And you could see it repeating 0, 1 on the other primitive, on primitive 5. It's repeating. And it repeats on primitive 6. So primitive 4, 0, 2, 3. 0, 1, 2, 3 vertices. These, the ones from that side, from this side, from that side, from that side. And same goes for edges. If I switch to edges and select that edge, what do you think is going to happen? Point 5, 0.6, and primitive 1, primitive 4, and vertices, we have 4 of them. This vertex from that side, this vertex, and that vertex from this side. So now you could see that in Houdini, we don't really have edges. We have points, vertices, primitives. And the edge is a combination of these. It's the connection between points, primitives, and vertices. And primitives, they connect points together. They could be an edge and they could be a face. But why is it this way? Why don't we have edges? Like, maybe I want to do stuff on edges. Why isn't just there an extra tab here for edges? Well, it's faster for Houdini to worry about points, and that's it. It doesn't need to process more stuff. If it only needs to worry about points and things can be generated from points, then it would be way easier to do far more calculations per second. And what's the last tab? The detail tab. This tab is extra information about the whole geometry.
So such as a material or maybe even a value. Let's put down attribute create, and we'll create a detail attribute. Now we can see attribute 1 created at detail. And that is arbitrary. It could be anything. You could type whatever. And there's a number. It's just once. It's written once. Whereas if you add it on the primitive, now you could see it. It's written for each primitive. So it's written 9 times. If you add it on vertex, it's written even way more. Because if we go to this I button and see, we have 16 points, 9 primitives, 36 vertices. So this value is being repeated for each vertex. And say you have 1,000,000 vertex number, each one of these extra values, imagine you have like 15 of them, and each value for each vertex is different. It's fine if they're different, but if they're all the same, why would you need them to be here? They could be in detail if they're just the same value. This is why you would use detail. If you know the value, the attribute there is not gonna change per vertex or per point or per primitive, just put it in the detail. This is getting too technical right now, and it's okay if you don't fully grasp all of this. You will with time when you practice and learn more about Houdini. And do go back to this part of the video series just to refresh and really understand what's the difference between points, vertices, primitives, and detail, and why we don't have edges. And once you start working with tools that manipulate geometry, this will get in handy. So we've talked about how geometry consists of points, vertices, and primitives, and they have a detail attribute to describe the whole geometry. Notice how I said attribute. All of these different types of geometry, they have attributes. And it could be color or position, UVs, it can be normal, and so on. They can be anything your heart desires. So they can sit in here. Each one of these has these attributes, and you can also do groups. And you can say from point 1 to point 20, you're in the group, whereas the rest, you're not in the group. So groups are good to isolate points or vertices, primitives, but you cannot do that on detail. This doesn't happen here because groups selects part of the geometry, whereas detail just it's a description of the whole geometry. So in the geometry spreadsheet, you would have the point numbers like that, 2, 3, and you would have the position, the attribute position, or any other attribute here, and the position would have 3 x, y, and z here for each point. Whereas groups, you could also see them in the geometry spreadsheet, but you're either in the group or outside of the group, in or out. And so on. So your geometry spreadsheet is really useful. You can get so many information out of it. For each point you can get, for example, for point 1 you can get the position on the z-axis, or if it's in the group or not, and so on. So this is really handy when you want to manipulate geometry and do lots of weird things. And we'll be using this a lot in the upcoming videos. In short, this is the geometry. The geometry can have attributes on points, vertices, primitives, and detail. And we can also have groups, and you can see everything if you click on the I button, and the attributes would show up here and the groups would show up underneath them. And with those different types of information, we can manipulate geometry and do lots of things with them. This is all you need to know. And for the rest of the video, I'll show the technical details. You could just skip ahead, go to the next video and keep watching, learning and doing. But if you want to know how things work exactly, keep watching. And if you feel like it's too much, you can always come back later to it and just get that little information you want. I'll put down a color. We can see the color, it's at CD, the CD RGB on points. I'll change this, maybe put this to 0. It's on the points. I can put it on vertex or primitive or detail. So what's the difference? Well, if it's on point, then each point holds that information. So I can do things like, let's say I selected this point. You could see the banding here. So it's this, but it's trying to go this way, that way, that way, and that way. Okay, so how is it on vertices? Let's say I selected that vertex. It's just that part of the primitive. What about the primitive? It takes the whole solid square. And detail, you cannot really select. It's just everything. Detail is either on or off. So with these, you could see the difference between how the attributes are acting, and we're using groups. This is a built-in group. It's this group node, but it's inside this color. If you double click, you go inside. If you press U, you go back up. So inside there's this group node, or another form of this group node. But let's try to group something after the attribute. I'll use also points, a group of points, and I'll select this, this, this. And you could see them highlighted down there in the geometry spreadsheet. I'll go to this I button, and now I have the attribute color, position, and group 5 with all the other information. So with groups, I can isolate selections and do different type of operations before or after, anywhere in the network. So let's look at the different types of groups. We have primitives, points, edges, and vertices. Well, this looks different. We have edges and we don't have detail. So why is that? And did I lie? Do edges exist? Well, no. We talked about this. The edge is a combination. If I select an edge right now, this one, it's a combination between 0.9 and 10. So why isn't there detail in here? Well, why do you even need detail with groups? Because groups are supposed to isolate selections and do things on one part of the geometry different from the other part of the geometry, whereas detail would just do the same thing on the whole geometry. So how would you delete an attribute? You could try delete. Well, delete selected, maybe not selected. This deletes the geometry. it's not gonna work. So maybe blast. Well, same thing, this deletes geometry. We need to delete attributes. Attribute delete. And now I can select the color. It's gone. There is no color in the vertex, but if I go to this one, which we selected the vertex, now the color stays, but we deleted it. We deleted it on point, but if we delete it again on vertex, it's gone. Same thing, delete it on primitive, and now we need to delete it on detail. So this delete attribute is gonna delete color, 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 color for point, vertex, primitive, and detail. So any of these plugged into this would delete the color. Notice if you try to delete the position, you cannot delete the attribute position, it's the geometry. You can delete it in this way, in these. But things like add CD or we could do maybe UVs. So let's say you had some UVs here. Now we can see this extra, under vertex, we have UV attributes. Plug that in here. And now under vertex, this would show up as UV. So I can delete it. And you don't have to select it, you could just type it. So there, space, UV, and it'll go away. We can also create attributes. And it can be any attribute. A, B, C. It's under point. If I switch it to primitive, it's now under primitive, and so on. I see we have a curvature attribute, and that came in from their curvature. The auto UV created a curvature attribute, so we can see it under points there, and I can delete it if I don't want it. If you want to delete everything, you could just do this multiplication sign, and it'll delete all the extra. So anything doesn't matter, it's gonna delete it. We could also do one really cool thing. If you have UVs on one model and you want to transfer them to another model, you could attribute copy. Just copy that. If they have the exact same topology, point numbers, and everything, but maybe they're just transformed, they're somewhere else. Let's say they're over there. What we could do is take the UVs. So right now we're just doing the color, but we could also do, it's on vertex. We need to transfer them from vertex. Oh, I see. So we deleted the UVs. So I don't want to delete them. Now they should show up. Yeah, there. So this, and that left part is UV, the right part is not. But with attribute copy, we copied the UVs. Just like that, from one part to the other. We could do so much more with attributes and groups, and we'll utilize those things in the tool building videos. In this video, I'll go over some breakdown, the Houdini breakdown. But here's an 80 level article if you want to see the overview, a general look of why and how I did things. But for this video, we'll go through this network. And I copied and pasted that whole network in here, in this file, which I will share. You probably saw it somewhere in the files, and you could go in, and there it is. That's everything, all the models I used in the scene. So let's begin with the stairs. And we went through this one in a earlier video, but I'll show you a few extra things. And I'm just gonna switch this with a stash, and I'll explain why. And hit stash. Now I can cut that, and I'll color this red. Okay, put that in here, that there, and I don't need these anymore. The reason I did that is, if you look at the information of that file, the original stairs with all the geometry, it's about 80 megabytes, and after the poly reduce with the UVs and everything, it's 2 megabytes. So when I share the file, this would be easier. You probably wouldn't see these. I'll just delete them for now. Okay, this part here was just some box modeling to get it ready for ZBrush. Then I put it in ZBrush, added some edge damage, put it back in here, poly reduced, UV, all that stuff we talked about. And I'll start going through these one by one, and we'll do it as fast as possible. So be ready for a lot of information. And you have the file, you can go in and start deleting, cutting, adding extra things to everything in here and understanding what each thing does. All right, so now we have that stash with, so the soft normal, you know that, just some normals. UV flatten, right, UV edit. I just moved this to get those front ones, which I showed in an earlier video, so let's just skip that. And in the end, scale, and the attribute copy to copy another UV set, which if you go to 5, you would have them both, right? In here, what did I do? So paint pattern, yeah, I tried one thing in here. I tried using these as decals. All right, so let's try and visualize this. And so that was before, they were just straight lines here, and with a ray node you could snap them. I didn't end up using these as a decal. It didn't look good. It looked like a sticker just floating in front of it, and it didn't blend through the texture. So what I did in the end, I actually added that inside the material, not another mesh on top, but actual texture on another UV set. That's why we have 2 UVs here. And with that, I was able to blend them, which I showed in an earlier video. So this whole thing was obsolete, so you could just give it that black where it's not being used, just so you would know later on. That's how I color things. Right, so again, this is just another stair. I'm gonna delete these. This is the stash. It's way less, it's like 3 megabytes. UV flatten, just cutting some seams and straightening everything, right? UV edit so you could move some of the UV shells around. Duplicate, this is the same thing as copying, attribute copy, but you could do it also on a vertices in a wrangle where UV2 is also equal to UV. So this would also give you another UV set. So there's multiple ways of doing the same thing. Right, let's open the geometry spreadsheet to make it easier so we could see what's happening. So UV, we have UV0 and UV2, right? So something changed here on UV. So what's happening is on UV, we're getting some information from this side in. We're transferring things with attribute copy. So group delete, just deleting all the groups. If you look at the I button, you have two groups here, and the group delete, there's no groups. Just some edits. And scale by 100 for Unreal. Name, a null. This is a null, just null. Null. Yeah, but I did that and named it. So I named them because in the FBX, this is the output FBX. If you're using Apprentice, you would probably be using a file. This one. And with that, right, I didn't do it here, but oh, did I? No. Okay, so what I usually do, I add this extra bit here, up input, and I get that. If you middle mouse, you get the, where is it? The name of it, s_small lamp, which is that it looks at the one above it, the name of this one. And you could also do it and name it here, but sometimes you want to export it in multiple different ways. So this is a cool way to get this extra part with this expression. You don't have to know these, just save them somewhere and reuse them. It'll make your life easier. Okay, apparently I didn't use it on this one, but I used it on the rest. It's just convenient, you don't have to do it. You could name them manually, but I mean, if you're using Houdini, just automate as much as possible whenever you can. Just makes your life easier. Oh, this part is somewhere in the background there. You probably don't see it, but okay, let's look out how we did this thing. So by now, you should probably be comfortable with bigger node structures, so this shouldn't be a problem. Let's go. Line, and I use lots of wrangles, and it's some small code, it's not much, but we can talk about it. Rent is a function which rounds. So if this line was just a little bit further, it takes it to the closest. It's like snapping to the grid or something like that. Okay, extrude, and placing with a transform two of them. Fixing the normals. I did this whole fancy thing which ended up not being so useful because you could just use normal and switch that to face area and it does it. Or you could also use soft normal and it does almost the same thing, and it has a harden UV as well. Okay, selected a few groups. I don't think this is necessary, but let's continue. Yeah, copy that, then transform, copy on and rotate. Right, what about here? A curve, and use that same function, the rent function, to snap them. Right, another, just some rotation, and this is, like we said, not that useful. And just copy. Yeah, so this whole thing is just copy. Yeah, the divide, you could use a brick polygon and it'll see how it adds these. Usually the divide, you would use it like to triangulate things, but you could also use it to add these extra cuts. You could see them here if I try to change. Yeah, anyway, so these were useful for something. Oh yeah, when you have too many thin
triangles, especially when they're that long, the engine doesn't like it. So adding an extra few cuts and having that triangulation here instead of the whole way over there, it would be easier for the engine to render it. Right, some boxes, copy and copy. It's just some boxes, it's not anything fancy. And right, attribute promote, and yeah, this whole thing is unnecessary, these. And divide, there it is. So the triangulation is much better now because the engine prefers it this way. Auto UV, layout, right, this is a bit horrible, but right. And yeah, this is color, and you could add color like that, same thing, do this like that. But with that, CHV is a channel, and I'll show you that in the few upcoming videos. There, okay. Next, right, this is that thing. Let's just lower this for now. Okay, I drew a curve, mirror, extrude. So the lattice we used multiple times before. With here I did an edit, but we had a mountain instead. Mirror, other side, polyfill. Put it to triangles. It's better for so it works consistently. Clip, okay, polyfill. Some bend and auto UV. The other side is some polywires, yeah, just curves, resample to get some more points, and polywire. Right, so these are some repetitive things, and we'll skip over whichever feels repetitive. We did a similar window. This is a smaller one, but let's dive in. Didn't use that, okay, so some boxes copied, long, no, not a, right, what is this? Face, right, so one clip, extrude with an inset to go in, poly extrude another one, delete some area, you could just select them. So this is not as procedural, because if you change something up there and you have a manual selection, these will break because the point numbers would change. So you cannot change that top part, but you can change things from here and downwards. Another clip, right, some poly extrusions, and in the end poly reduce, divide for the triangulation. Merge, what do we have here? Right, so a curve, extrusion with some playing with the thickness there, you could see how it does that. Extrude, the soft transform, I selected a group, so it's just some points, you could see it there. And scaling things. This is good to add some extra wonkiness. Right, some extrude and transform into place. What about these? Right, same thing. And this is just a sphere. What happened here? Oh, I'm just switching, flipping the normal so that the extrude goes the other way. A bit unnecessary, but alright. Polyfill. This soft transform helps with just softly transforming multiple points. some rotation. Okay. What now? What do we have? What? Oh, we talked about this. We'll just delete this. We have it in the other. Okay, what do we have here? Oh, this is the window with some more detail. So what's the difference? Right, some square. Boxes, copied boxes, copied boxes. All merged. What do we have here? Few boxes and a cylinder. Everything is beveled and in the end just put together. Layout. You should probably stack identical so you would have more space. And just export. What about here? Yeah, this is this part. So with this image, this was made after a reference. What was it? There. So I didn't have to build a whole big scene. This was the whole shot. So for me, all I needed to do is just add a few building faces here and there and call it done. So if you see the scene inside Unreal, and you try to go like this side, everything would break down. The scene only works from this angle like that. And that's good enough for this project. Right, this is just that side. So I'm just gonna skip over anything with boxes and bevels. Like, that's not interesting. We'll look at some more. Right, this is for the decal. Okay, so what happened here is I have this part of the decal, and in Engine I'll transform the UVs to this part, that part, and this is how I would sample different parts of the same texture. So I wouldn't have to use so many materials for each decal. You could use like 8 or more per decal. Right, some box, and export that and put it in ZBrush, add some detail, put it back here. I'll delete this and keep the stash. This is way smaller. Right, what do we have here? Some extra extrusions and lattice, and okay, there's a balcony here. I didn't end up using this, but we could check it out. Let's go in. So this, if you have a few faces, all right, extrude them, then, so what's happening here? Anyway, so if you have a few faces here, you'll get the outer edge with a just dissolve. Keep that edge. Resample. Right, what do I have here? Go. Some code. Okay, we're not gonna get into that. And I don't think that's necessary. This I was just playing with this. We could do another thing. You could literally just copy a line. Just CTP, copy to points, and a line. Just do that. And that's the point. And we have the same exact thing. I think I was just trying to not use there. oh, this is taking a certain group, and I messed up that group when I moved things, but we could just not use that for now, but you get the idea. All you need is to select procedurally the corners, and that'd be it. But this whole thing was really unnecessary. I was just playing with it. Just an extrusion, and bevel in between. You could do this with a boolean, or right, just let's keep going. What do we have here? This is a bit more interesting. It's just a few lines and they're polywired. We have a line like that, a line like that, merged, copied, resample for more points, mountain for some variation, and the polywire. This part is just 2 of them. Polywire on 4 divisions, polywires with some mountain, polywire all together there. And the interesting part is here. So with the auto UV inside a for loop, what happens is everything gets auto UV'd separately and they sit on top of each other, instead of if you do this, everything is this small, but inside a for each loop they happen separately, like per object. And I probably needed this maybe to put it on a trim or something. Then scale, give it some color, and name, and export. Right, some more interesting objects, I guess. Let's go in there. Right, a circle. So there's many ways to achieve this, but this was one of the first ways I thought of. So let's see what happened. So a few clips, polywire, okay. Wrangle, what is this for? Oh, this was deleting the primitives with more than 4 sides, so you could see that. And you could totally just copy and paste this in a primitive wrangle if you have the same problem trying to delete faces with more than 4 sides. This is probably useful. And right, oh, I used a bounding box here. So you could see this bounding box, and that's the box. I used it just to get the lower part, then just transform that. When you want to transform a certain part, make sure you add the group. Match size to put it in place. UV flatten. Alright, I did this probably manually, picked a few seams, and then yeah, so you could see let's visualize the seam. There. Some more clips and they're transformed. So these things are happening like manually. This is not too procedural, which means if you try to change stuff, it'll not behave properly. But this was a very specific thing I needed, and that is okay to do. I mean, do whatever you like. It's probably no right or wrong here. Just let's keep going there. And yeah, just the same stuff. So a curve, revolve. This is, I haven't used this until now. Revolve, you would have a curve and it'll revolve around the center and it'll make this shape. Right, extrude in, some bevels, and bevels with a sharp angle, so it only bevels the 90-degree angles. Transform it into place, and these are some other smaller bits here and there. Just put it on top of each other, and that's the final thing altogether. UV'd there, right, polyfill. So just to fill those holes, and auto UV. What about that side? Yeah, sometimes things act a bit weird, and you would have to UV things a bit set in a different way. So this part didn't like the auto UV, so you would UV it in a different way, then merge them back together and lay out in the end. And it's better if you keep all your UVs inside a subnet instead of having a big list. So the object, the UVs, and then just some divide, normal, the lattice thing to give it some animated look. Alright, group, so just color a certain group. And I used an F. You could do another thing with like a color here and use this group here. Let's say this would be, I don't know, green. What do we have here? What is it? Which one? Group red. Right, I want group red to be green. There. You could do that way, or with an if, and that's the if statement. So what happens is, if a certain group is equal to 1, which is true, the color is that thing, and you close with a semicolon. Right, attribute. So from primitive to vertex, because Unreal Engine works with vertices, it's not gonna show up if your colors are on primitive. This is just visualizing it. All right, let's keep going. What do we have here? All right, that thing. And I think we talked about this at the start of the video. So no, I think we talked about that one. All right, so let's cover it. So at first, I usually put down a scale, and then I would start breaking down that thing. And so, right, so we have the box with some bevels, and this part here, let's go in, a curve, or half a curve, and resampled this. Right, this is the thing I mentioned earlier. You could just flatten one axis. So right now this is the Z, and there's no Z anymore. It's all 0 on Z. Mirror, extrude, just the front part. So the extrusion gives you a group, extrude front, and that you could use it to scale it on its own separately. Right, and extrude downwards, then copy, transform. Right, that's sort of a cage thing. Let's look at it. Just some boxes copied around. Extrusion with a bevel. And what about this? A bevel on a crease. A group. Delete the inside group. Alright, some extrusion to give it some thickness. All together merged. Some auto UV. UV layout. Subdivide, okay, lattice, to give it some shape. What about this? Right, 2 handles, the back, with a curve, of course, just some extrusions on a curve. Really quick, transformed twice, merged. In the end, some different colors, and these are, used inside the engine to color it differently. There. And I'm using these. This is how useful the groups are. If you group things way before here at the start, at the end you could do other things such as color them differently or move them separately or do that type of stuff. And what about this? Yeah, primitive to vertex, so that you would be able to use them in engine. So primitive, they were here, to vertex. Now we have the color here. There, some of them should be one. Yeah, that's the red, and yeah. And you could see the groups all over here, and you could delete the groups if you don't need them. It'll just lower the file size just a bit if you're worried about that. What about this? This is that thing. Okay, I think it's probably the same stuff. We're just right, 2 lines and a fuse. So a fuse with on a higher, you could see how points get together and extrude. So it's the whole thing is it's either a box extruded or beveled. Some parts of it are deleted with a blast, or it's a few lines and those lines are extruded. Finally, some lattice and UVing. If you want to assign a material, you could, and transform by 100, give it a color, name it, and export. It's the same stuff repeating over and over. But let's keep going, and we'll just cover the interesting parts that are a bit different. So what happened here is, all right, I'll delete this. This is another stash. This was from the engine, a blockout in the engine. So instead of me trying to approximate the size of this thing, I just got the blockout in here, scale it down, got part of it, and match size just to put it in place, clip it, right, I don't need the bottom, just do that, right, some beveling and subdivide. That would go out into ZBrush, comes back in here, right, with some extra detail, edge damage, stash, I don't need these. You probably keep them, of course, but like just for so I could share the file with you, I'm doing this. Right, some auto UV, this is horrible, I don't care. And if you really care about the your assets and you want to make it run at like I don't know, 120 frames per second, you probably give it some more time and make it look nicer and the UVs are nicer. But for an ArtStation post where like, oh, you're just having this one shot from this one angle, who cares? Like, no one cares. Just finish it as fast as possible. And if you need to optimize and fix things, you could always go back, because Houdini, like, you have them, you have everything, you have the this is not just history, this is history with more possibilities, because you could go off from whatever branch you want to branch from. So at any time I could go back, oh, the art director would be like, oh, this is unacceptable, fix it. I'll go back and I'll just do another branch here and fix it. Maybe I have another tool that kind of fixes this problem. I bring it in here, add it on top of this, and done, export. Right, so this part is a bit weird. I was trying to make some optimization tricks where I was using the red color as an index, the vertex color as an index in engine, in a way that I would be able to lerp multiple textures in the same material per index. This is some tech art stuff which you probably don't care about, so let's just keep going. And right, so this part is that stairs. Okay, so a curve, with some extrusion, the same thing we did in the past, right? This is some extra little bit information down here. So what is it? Okay, what is it? What is it? Some extrude with a group. I'm just extruding one part and keeping the other down here, but with an extra bevel, it looks nicer. Wait, what is that? I'm just gonna lower this. What happened here? We have that thing, and you mesh it together with a VDB. I mean, that's a bit overkill, but maybe I needed this nice transition here instead of this harsh angle there. And you know about VDB. You go inside VDB, do the reshape, go back out. Just copy it. Right, merge in the end, auto UV, the whole thing. This is horrible. But who cares? It's that far, so who cares? Hey, I'm showing you like behind the scenes stuff, so don't judge. Right, so yeah, this is the most horrible thing in the scene. Yeah. You probably need to do this a bit more modular. So what you would do is get a chunk of this part and maybe that part, and then you could start building the scene with it. But I didn't really care that much. Right, and yeah, it's just some random. Right, that's a vase. A bit more interesting. Let's go in. A circle with an extrusion. Some more extrusion, a group. What for? Let's see. No, I'm just grouping a certain part there with the extrude side. So whenever you extrude, you have extra groups from the extrusion there, that side. So that group combined. Okay, I'm grouping two parts. And then I could extrude just the outer part, because when you do an extrusion, the group side is this side group and that side group. But you could do the inner faces. What are, all right, so there's something with the scene. There's something not showing up. Let's try again. Yeah, I figured. So sometimes you need to put another scene view just so you could refresh, because that highlight wasn't showing up. So the other group combine, it's the group combine helps either subtract or add groups, and right now I'm doing an intersection so that I just can get one part of the side group, and all of that just to push it a bit higher. It was probably better if I had done this revolve thing where I could do a curve here and then curve like that and do the revolve. That would be way easier than doing it this way. But hey, I did it this way, so let's just keep going. All right. What do we have here? Just another box, okay. Right, this part is these. And it's literally a box, another box, and copied. So let's keep going. Oh, this is the curtain, that one. And you could see how it's colored a bit red up here and dark down there. It's in the engine when I'm using the vertex color, I'll move everything except the red part, so this would stay put. And let's look really quick here. Right, so it's a grid with a mountain to give it some deformation. One thing about a mountain, it only works on actual like when you have geometry with edge loops, but if you have points in space, like let's say this point, and you try to do a mountain on it, it's not gonna work. It needs a surface with normals. so it's good in this case. Right, UV editing, I'm just moving that part, the outer part, somewhere else. Right, so that's the color. So we'll talk about ramp. It's really good with gradients. It's like that gradient thing we used way back on the power lines. Right, what do you have here? Some extra geometry, yeah, extrusion from there. Fixing the normals and extrude again. Subdivide, UV layout, mountain, some manual edits, and just merge in the end, bend just a little tiny bit, right, and scale up, export. This is a bit more interesting, so let's look at it. It's using vellum. We used vellum earlier, so you put the cloth, and then, right, if you group a few primitives, and then the constraint helps with just constraining those points or primitives. Solver to do the simulation, and a post process to give it some thickness. And down here I did some weird thing with blend shapes. So I did this trying to optimize it in a way that it loops from one blend shape to the other instead of exporting a vertex animation texture, which is probably an overkill in this case. There's a lot of points. There's another way with dumb bones. Just plug that in here and convert and export, and it would make a skeleton for you. I was trying to get around the idea of vertex animation textures because of the lighting in engine, especially Lumen. With when you try to move vertices in the shader with Lumen, the lighting doesn't work. So I was trying to hack it in a way, trying to use blend shapes. A skeleton would be a better idea in this case, but I was playing with this anyways. Let's go here. Yeah, we talked about this one. What about this? Yeah, it's that part over there. So I mean, these are some primitive shapes. They're just latticed and bent in a way, moved. Okay, so what do we have here? These are the curves. So what I did is used some curves and then snap them. So minimum position, it's like that ray node. It does that almost the same thing. There. It tries to snap to those collisions there. And once I have that, I resample and polyframe. Okay, it probably helps with the oh, it's unnecessary. And some black color for the engine shader I was using. Yeah, right. Let's go. What's the other one? Some boxes and wires, same stuff. Right, wires, so we have a line. That's the normal of the line. Okay, so see how there's no normal, but with this and one on the X, one on the Y, 0 on the Z. This helps zero out any chance of it going on the Z axis, because if there is no normal, the mountain wouldn't work. So it's gonna work up and down, left and right. Curve, right. What about this one? So this is a parabola, the equation on the y-axis, but you could also do it with the gradient way we did it earlier. Okay, copying some extra stuff. Did I do anything special? Oh, the scale is a bit randomized per prim number, and per prim number because 0, 1, 2, 3, so this whole thing is a prim number, whereas if I do it per point, it'll scale differently per point, and I didn't need that. I just wanted the whole thing to be a bit bigger or smaller. And for now, just copy these and paste them if you want to use them, but we'll talk about them. All right, same stuff. There, a box, and a few curves. All right. Here's some interesting thing. You could use a spiral, and I just put it in place. Did that gradient thing to lower everything down. Okay. This is to add some randomization. Then smooth, sweep along that curly thing. Added some gradient here and there. So that in engine I would only move the white part, and you could also use there's a cable tool inside the engine, but it didn't look visually pleasing, but these parts done this way looked way better, so I went with this technique. And here are some more variations of the same thing. So that does it. That was a lot, but I think you could see how everything is a bit repetitive in here. There's nothing that fancy. I mean, there's a few fancy like snippets of code, but that is totally doable once you start getting into some Vex, and we'll talk about that in a few videos. Let's get out of this nutshell. We've been working in SOPs for the longest time now. All of this is SOPs. It's inside object lab. These are objects. So we can put down another object and maybe turn that off, go in here, make a, not that big, right? There, turn that off. So this whole thing is geometry, it's surface operators. But we have other stuff. What are these? We can access them also if we press N and hold it. Could go to materials. I can do classic material, classic shader, put that there, change some parameters there. Right, but this, you're probably not gonna use it in Houdini. You could just go to stay in SOPs and do material, labs material. You could also switch it to PBR and plug in a color, roughness, metallic, normal, occlusion, the things you're used to. So what side effects did is they brought the other context to you, so you could stay in SOP land. You don't have to go to other. Even ROPs are the out, which wherever you want to render stuff and push it outside of Houdini. If you have Houdini Indie, you have the FBX stuff. So you could export things with this. When you save to file, it says ROP FBX output. It says ROP because it's actually in here, but it's showing up in object level just for you, so you could use it. I think even the file, when you're exporting, it's sort of doing that in out context, but those nodes show up in here just so it makes it easier for you to keep working in the same space. You don't have to keep jumping between things. But let's check out cops. So cops are, they're similar to substance designers. So if we put down a file, and they look a bit different. They're not we can minimize it, but you could also see, but I don't see anything in 3D. It's in the composite view. There, it's images. We do image manipulation here. We could do things like blur even more, and so many other effects. And you could experiment with these things. And if all of this is not enough for you, you can actually put down some generators and go inside, and you have more options where you could do some addition, multiplication, all that mathy stuff. And we'll talk about Vops in a future video. All right, so this is COPS, image manipulation stuff. We can go back to object. So we talked about all of this for, well, what is LOPS? Just don't worry about LOPS for now. It's stage, it's USD stuff where it's probably gonna be one of the future workflows that most companies use, because USD would make it easier to transfer data from any software to the engine, back and forth, communicate with things much easier. It's a workflow that Pixar has created, and everyone is adopting it right now. And you use stage LOPS to do that stuff. You'll probably hear more about it in the future. So what is DOPS? DOPS is that thing we used. It's showing that simulation we did with the physics inside this DOP network. It actually threw me somewhere here in our original file. Yeah, there. So DOPs are the dynamic operators, and that's what we did with them. So what's happening is inside the DOP context, things are happening, but we wrapped around them a node so that we could see them inside SOPs. There is one more context that is not showing up here. It's the channel. Channel, not a lot of people use it, but the ones who do, they make crazy stuff with it, such as they make MIDI controllers, and someone made music with it. So let's just put down a noise and see what is it. Well, we cannot see here anything, so let's go to there. So with, without, there. So this noise, you could control it, the amplitude, right, frequency, harmonies. There's a bunch of parameters. And that's just noise. So people use this for animation, anything with curves. This is really fast. Animation, curves. Just imagine this is a mountain from the side view. You could use this as height. This is information, and information can be used in multiple different ways. You could drive texture workflows with this. Maybe the X is 0 down here and 1 up there. That's the red channel maybe, and just go where your mind takes you. You could do lots of things with this, but we're not gonna cover all of this in the tutorial. This will be an environment art friendly tutorial, and we'll stay with SOPs. We'll play in here. One last thing is tasks, and that's PDG, which is it's a thing where it makes it easier for you to spit out lots of different variation. So basically you tell it, I need all of this to be rendered, and you just leave it. You go to sleep, wake up in the morning, and it should be done. But for this tutorial, we'll stay here. Anything else, any other context, you can learn it afterwards way easier, as long as you understand SOPs. Time to learn some VEX and Vops and other stuff. So what's the difference between VEX and Vops? I'll put down a wrangle. In here we write vex expressions, and there's also an attribute Vop. These are vector operators. So what's the difference? Well, first, this you could dive inside and you have another network in here, and this goes left to right. If I plug that in here, this is a null, so I'll just put down a line. And we could do that here. So let's do the wire thing we did with that gradient. We did it with the labs gradient before, but we'll make it again in Vex, and we'll do it again inside Vops, and we'll see the difference. So this is like Unreal Blueprints, but this is like Unreal C++. So that's almost the difference if you want to compare it in a way. Right. I'll just put this on this axis here. Right. So on the x-axis. And we'll try to, let's just add some extra points. Cool. This is taking too much space. I'm gonna lower it. I'll open another one here. And I need the geometry spreadsheet, and I'll just keep that down here. It's really useful to keep it on at all times. You don't know when you're gonna need it, or sometimes you change something and something immediately changed here, and you would catch it immediately, and this would probably save you in lots of cases. So just keep it on, like down there in the corner. Right. So there are a few attributes and geometry types that we talked about, and we'll utilize them right now. If you go inside the Vop first, you can see how these are all of the attributes, and so this is the position, velocity, there's age, that's the normal, it's not showing here, but it's a vector that goes from each point. Point number, primitive, so point number is these, and we'll use this point number to make a gradient and then lower just the middle part, so we'd have this spline which we can connect to power lines or any other thing that requires this type of geometry. Down there's the inputs. So these 1, 2, 3, 4, but we start the count from 0. So, I guess it's counting from 1 here, but they're usually, when you're trying to reference them in a wrangle, they start with a 0, 0, 1, 2, and 3. Right, and there's some other stuff. So CD is the color, and we're not going to use all of them, but they're here, and if you forget what they are, you could always put down an attribute triangle, go inside and see them. Right, let's do a gradient first. So for a gradient, we could use the point number and the maximum point number. So the maximum point number is the number of points, whereas the point number is the point number of each point. So one thing you should know about these two, they are sort of a loop thing, where they would loop over all the points. So just like we used for each point, like that, and if we do single pass, it'll do this. It'll go over each of the points in the let me just increase. There's there, large, yeah, okay. So just like this for loop loops over all the points, this wrangle and this attribute Vop, they loop over. Right now it's running over points, so it's looping over points, but if you switch it to, let's say, primitives, it's gonna run over, well, there's 0, there's one primitive at right now, so it's just gonna run once, but you get the idea. And right, so we'll leverage that point number to make a gradient. I'm just gonna lower these a bit, yeah. So from 0 to 24, and I could divide the point number by the maximum point number, and you'll understand in a second. I'll put that in the position. So at p is position, and the at pt num is the number of point, which we saw in here. The pt num is the number of points. Don't worry about the error, we'll fix that. This is divide, then at num pt is the maximum number of points, and we'll close that. Right, so we have a slight issue where everything is on the same, on the 0 axis, and that is happening for a very specific reason. If we go inside here, see how these are colored this blue color? These are integers, whereas the life and age, and these ones are float numbers. So there's a difference between float and int. So a float is numbers such as 0.0, that kind of thing. They have decimals, whereas integers, they're just this number, like either 2, 3, or so. Right now, these two are integers, and when you're dividing integer by integer, you will get another integer. You will not get the decimals between them. So it's complaining right now. Everything is not gonna work. So we'll multiply this by decimal. Now everything shows up. So what's happening here? From 0 to 24, and from 0 to 24, and we're dividing the point number by the maximum point number. So we're dividing 0 by 24 at point 0, and 1 by 24 at point 1. So technically, if we look at the geometry spreadsheet, the last number up there should be 1, because 24 divided by 24 is 1. Well, it's almost 1. It's going on all the 3 axes right now, the x, y, and z, because this position is a vector. This p is a vector. The green ones are vectors. So we need to switch this from a vector to just the y position. So if you want to access part of the vector, see how down there it's 3 values, it's x, y, and z. I just want to access the y axis, this. I just want to modify this one, not everything. So I'll just do dot y, and we'll go on that axis. If I do dot x, it's not gonna work here. Dot z, there. Oh, because it was already on the x. Right, so y. So we have a gradient, but that's not what we want. We want this type of curve. So how do we get this to that? Well, we could use this gradient and remap it. As long as the gradient is increasing from 0 to 1, now it's 0 to 24, but it could be also from 0 to 1, then we can remap that 0 to 1 to 0 to negative 0.5 to 0. We could remap things. So we'll take this whole thing and remap it. Okay, so a few things about coding in general. The code runs top down. It starts with the first line, then goes to the second, then to the third, like that, goes from top to bottom. And we could do things such as store values inside containers and reuse them later on in other places, and like later on down there. So instead of putting this value inside the position, the Y position immediately, I don't want to change it right now. I want to change it once at the end. So I could do float, because it's the value, the end value is a decimal. Float A. Float A now has this value hidden inside of it, so it's there. You're not gonna see anything, and it's not gonna show up down here. You could force it to show up down here if you do this f at A, and now you could see how that's exact same value, 0.96 we had earlier. And if we try to just calculate another number, let's say 16 divided by 26. Okay, let's do that. So it's supposed to be 0.61. So at 0.16, 615. So we're getting that gradient value we want. Cool. Now it's hidden inside this. Well, it's not hidden because we can see it in the geometry spreadsheet. So we're printing that out here just for us to be able to test the values and see everything. So with this, I'm gonna do the at p.y. Now I want to change the y-axis, but I want to change it based on a ramp. So I'll just do this thing is gonna be equal to at p.y. So it's gonna be equal to itself minus chramp, close it, and inside. So this is the ramp. This is a function provided by Houdini, by Vex, and we can use that to do we'll put that value, the one we had up there. So this value, and it takes another argument here, which is the name of the ramp. Name ramp. Okay, so maybe that's a lot, but let's go through it again. So the position with the Y position is the Y position, but it's subtracted by a ramp. And that ramp takes these arguments. And arguments are a thing that sits inside this function. And how can you know what these arguments are? Well, if you go and Google this part, and you don't, when you're in Houdini, you don't have to Google things. You can do F1 on the blue function, and there's an internal documentation inside your Houdini file, and it says float ramp. So the function ramp takes a string, channel, and the float ramp thing you wanted to. So the ramp that float is the f at A, which is the gradient we just made, whereas this is the string channel. This is just a name. It doesn't do that much. It's just a name. So let's try and click this button on the right to make the ramp. So something happened here. See how it's increasing? We could change that, do that there, and now we have It's almost there. So let's change these to spline. Okay, and there we have it. And you can keep editing that. There. Yeah, I like that. Okay, so as we can see, this is the name ramp, and it's there, name ramp. And that's the gradient which got remapped with this function. And the gradient, as you saw earlier, it was that thing up there, which was the 0 to 1, that line, increasing line. That was changed to this curve, based on this curve. Okay, so this was Vex. Now we'll repeat the same thing inside Vops. I'm gonna copy all of this and I'll go inside the Vop, put down Shift P, just so we could see it, and we'll replicate that here. Okay, let's start with this line right there. So we need the point number there, ptnum, multiply it by a value, a float value, so it turns from an integer to a float, so we can have the decimals. Then subtracted by the number of points. We'll do that first, then we'll try to do the ramp. Right, so pt number, point number, which are these. Okay, and we need to multiply that. Let's multiply that. Multiply by a float constant, and yeah, it's float. It's already a float, but see how nothing turned? This light blue and this is dark blue, or blue and cyan. So this whole thing should turn cyan. So this should go first, then that. And now this is a float. See the end result? It's turned to cyan. Now it's a float. Cool. We did this part. Now we need to divide by the number of points. So I'll put down a divide. Okay. This divided by that. Okay, let's put down that there. Oh, this, I see why. Oh, there, that was the problem. I didn't put a 1 inside the constant. I was multiplying by 0. Like I was doing this, 0. So we needed a value there. Right. So now we have that gradient, and we have the same problem we had earlier with all the axes. But I just want one axis. So this is the same value going into, so this is a float going into a vector, but it's saying on the x-axis it's 1, on the y it's 1, on the z it's 1. But I don't want that. I want to keep the values as is, like that. They stay the same, except on one axis it goes down or up. So we need to break this vector and just change the y-axis from it. So we'll do vector to float. And then we'll remake it again into a vector. So f to v, float to vector, instead of writing the whole thing. And I'm just gonna do this dumb thing where I'm just gonna do this and that, okay? And nothing changed. So what I did is position goes into vector to float, then the x, y, and z goes to x, y, and z, then goes back to, so nothing changed. But now I'm gonna cut this y part and replace it with this. There. Cool. So we have the gradient. So we did that first part there. But right now I'm changing the position. So what I'm doing right now is this. I'm doing the y with that. But I don't want to change the y just yet. I want to change it later when I do the ramp. So let's not do it just yet. Let's do the ramp first. Ramp parameter. Okay, so with that, we'll do the ramp just on the one axis, and then finally in the end, we'll put that there and there. Okay, so this ramp is currently set to color, but I want it to be a spline, so I can control this. But see this yellowish around it? This one node, the ramp, you have to go up a level to control it here. This would go here, and I'll subtract the ramp from it, and that goes there. We could do one last thing, and I'll add this to the vex as well. We could multiply this whole thing by a number, so times 2, and it goes even way further. So this, instead of increasing everything manually like that, you could multiply by another number and everything would increase. But maybe you don't want to always go inside here and type that manually, and you want another slider. You could do another chf, and this would be a float ramp, float value. So anything that you type inside these quotations, it's literally just a name. It's the string, which this is a string, is just a name. So you could type in here whatever. But the important part is the chf, that's the function, the blue part. This is a ramp, which gives you this, whereas the chf is a single float value. And these are extra parameters, and extra parameters need to be initialized from this button on the right. Alright, so this ramp is being multiplied by this number, and I can increase it or decrease it. I can flip it as well. Let's do that extra thing inside the attribute triangle. So make sure you always visualize whatever you're working on. Oh, there. So this was multiplied by that value, and I will add that right here. So we'll do multiply. So after the ramp, that goes there. It's being multiplied by nothing right now. So I'll middle mouse on this, promote parameter. See how it went to 0? because it's 0 up there. But I can bring it back to 1. Same here. So we did the exact same thing in 2 ways, with Vops and Vex. Let's do another example. Another attribute Vop. But this time I'm just gonna use a sphere. Polygon. Yeah, that's enough. Let's go in. So position to position. And we'll do the typical addition, subtraction stuff. So middle mouse to promote. It's going on all 3 axes. Whereas if I do a wrangle, the same thing would be at P equal at P plus a number. So it's that exact same thing. Instead of typing at P twice in here and there, what you could do is, since we're adding, there is a syntax thing where you could do this. So it's plus equals 1. So at P is, you add to it a 1. But let's replace that with a channel. And expose it. There. So that's the same thing as doing this. Adding. Multiply. Expose that. There. So the multiply seems to scale things because there is a vector from each point. So the multiply, it's scaling because all of these points, they're actually vectors from the origin. So these positions down here, let's say 0.5, let's look at 0.5 there. It's on the negative 0.8, 0.2, so if you go on the x-axis, negative on the x-axis, 0 to 0.8 there, and then there's minus 0.4 on the z, so that's 0.5. So there's a vector going from the origin to that point. And that's why when you multiply that vector, everything, all the points with their positions are increased or decreased. Whereas if you add to that vector, oh, so it's not going to happen here because we need to go back in and switch that. If we add to that vector, all these points are moving to some other place. So I'll just do this on top and we'll see that. Right. So I'll do both at the same time. So we'll add, then we'll multiply. And we'll see what's... Okay, so we're adding, then we're also multiplying. We could try to switch the order. Okay, what now? So is it the same thing? So we'll try in 2 different ways. either multiplying first or adding first, and there's a difference. Is there a switch? Let's try that. There, promote. Okay, so we could use a switch inside and either multiply first or add first. So this is exactly the same thing as doing that with the transform. Just moving like that and moving up a bit and scaling, but it's inside this attribute Vop. And we could do the same thing here. So we're adding, but we could also multiply. CHF, just another channel, and I'll call it multiply. So there we had it 2 and 2, 2 and 2. Yeah, but here it seems everything is bigger. It's probably, oh, I see. So I'm adding this to it, but what I need to do is add P plus, like that, and then multiply everything. Now it should, yeah, be the same. So play with the order of multiplication, addition, because if you add another number, then you multiply that with the addition, things would grow even bigger. This is just some elementary math, and we're talking about mainly the syntax here and what's the difference between a Vop and Vex and the regular transform. And I've written more on this topic about vectors and how they work, multiplying, scaling them, adding vectors, and you could see that on the blog section. Right, so let's continue with other more game-friendly environment art operations. Almost forgot. We added a switch in here, and I didn't do that in the Vex, so let's do that. For a switch, we'll need a if statement. So if a certain number is bigger than 0, we'll do this. So anything inside will happen if this statement is true. But we'll get an error if we do that because it's complaining. Let's see what's the problem. Well, it's that n right there. Reference to undefined variable. This is not defined yet. So let's define it. I'm gonna make it an integer equal and an integer channel. This is like one of those channels we used down there. So this would be the switch. This, anything with green is a name, so I just named it switch. There. So it's like that. Right. So what I did here is I stored this switch value inside a variable n, and then I used the n afterwards. So let's do that to these as well. I'll store this and I'll name it f. So this would be a float, f equal that value, And at the same time we'll do this, and I'll just do m here, and this is also a float, m equal there, close it, and it's still working. It's still the same code, nothing changed, but this is much clearer because at the start, if you do this, and you can type comments here, at the start it's the inputs, then do the scale and transform and translate. Let's go over the if one more time. So if a condition is true, you go inside those curly brackets, execute this code. If it's not true, it does not go in. It just skips over this. So the reason it's true is because n is bigger than 0, which is this number. N is 1, and 1 is bigger than 0, so we'll do this operation we did earlier. The position plus a value, the f value, which is this value. All of that is multiplied by m. M is that other value. And the mult is there, and foo is there. It's that same thing we did here, but we did it with Vops, and here it's with Vex. One really cool thing that Vops can do really easily is noise, adding noise. I'll do another sphere here with way more 50, yeah. This is not unique to Vops, of course. You could do this in Vex, but it's just easier in Vops because you could just type in noise and you get lots of different types of noise, or you just go here. Let's try the kernel noise. There, and if you plug it in, yeah, some weird stuff is gonna happen, and it scales all at once because the positions are being changed with a noise, and that's going back in, but you need to add that change. So we'll add or subtract, whatever. And now it'll stay in place, but it changes, either adds or subtracts if you go on the negative side. And you've got lots of different options, and they're all exposed, so you could play with them. Different types of noises, simplex, yeah. And that's just the kernel noise. Let's check out turbulence. I'll delete this. Put that in there. Everything gone on the same axis because this is float, whereas we needed a vector. Okay. Let's look at the unified noise. Somewhere there, P position, there. Noise, we need to switch that to 3D. Put that there instead. And it's, okay, it's a simplex. Let's put it to Perlin. Maybe more frequency. you could do the same noise from all different sides. With this, we're doing 3D noise, but if it was 1D, but we wanted to go along the normal, we could do displace along normal. Just plug that in the amount, and that would go there. So this noise would go out from that normal, like that, out along the surface. It's everywhere now, but we could mask it to a certain area. Let's try paint. We'll mask it with some color. I'm holding Control, and that's perfect for now. Okay, so since all of these things are attributes, we could see the color here, and we can multiply by it. So the 1 would scale up, but the black would stay put because black is 0. Multiply the color, but I don't want to multiply it here because this is gonna be on the 0, 0, 0. I want to multiply it just the noise, not everything, before adding. And now it'll stay where it's supposed to, there. So you don't need the add if you're using a displacement. But the displacement is doing something under the hood, and we could see that exactly by using the normal, because it's displacing this noise along the normals. So let's use the normal itself and multiply this value with each point's normal. So the vector normal, make sure the vector input is first, because that's the output. That would be the output, the green. That would be added, and there's no change. It's the exact same as using a displacement. So this is doing that thing. So we can get rid of it for now. That is one handsome feller. There, I think this suits him much better. Another thing we could do is color in a more procedural way. We're using paint here, but we could also do attribute noise, and that color would affect everything. It has a minimum and a maximum. And it's set to vector, but it could also set it to float. So it's just one value, black and white. This is the attribute noise. Another one would be the gradient, the labs gradient. we could flip it or do this type of stuff. Let's do this there. There's another way with a relative bounding box. So what this is, let's split it first so we could see vector to float. The bounding box is gonna sit around this shape and go from either the x value, y, or z. So we could use the, let's say, the y, and instead of going into the color, we could multiply this noise by the value, and that goes in. So the same thing we did up there with a gradient color, we could do inside with a relative bounding box. But it's not good to always use color to transfer information, because what if you want the color to be consistent? You actually colored your thing and you like it the way it is, but you still want to use gradients and masks in a way that you could control noises, but you want the color to stay consistent. So what you would have to do is use another attribute value. Let's say you want to use A, and it's gone now, but we'll try to get it in here in another way. So these are attributes, and A is there, but it's not there. It's not going to be added here, so we need to add that manually. Bind, we'll get the name A, and it's a vector, 3 float vector. So that we'll multiply that here, there, and we did the exact same thing, but we got this. This is just, imagine as if it's one of these extra thing, but was bounded forcefully. There's another way to bind export, and with that, this is like an extra output which you could name and specify. So let's try to output this, and we'll name it B, and we go out and we should see B down there. There it is. So I'll put down Wrangle. The color is at B. If I change it, let's try changing that. Yeah, it updates. So we're grabbing that color or whatever value it is. So you could see how this is supposed to be color, but we used a random variable A, attribute A, and then inside we got it, that A, and we did things with it. We multiply it, and we also exported another random attribute. We called it B, and we use that attribute as color. And that's what I love about attributes. You can initialize them at the start and not do anything with them here, do something with them there, make another attribute there, and use it down there. These are nodes, but in them you store other values and you use it anytime, anywhere you want in the network. And you could also transfer them to other networks, and it's information. And with nodes, we can build a tree of information with attributes that flow inside of it, from input all the way to output. Now that we've learned about Vops, we can revisit the rock generation we did in the past, this horrific thing. We can make it better. Let's make another system here with these attribute Vops. Before I begin, it's always a good idea to just Google it. So let's see what other people have done, and we'll take whatever we like and we'll implement it in our system. This seems kind of cool. Let's see what it is about. Okay, so we're cutting different planes, then using some Voronoi fracture. Okay, let's check another one. See this one? So the idea is from a circle to a rock with edges, then displace inwards some stuff. So with that, I think that's a whirly noise. Then some parts go inwards, add some extra detail in the end. Okay, so what else? Let's check Simon's. So we're starting with a few boxes and doing a lattice on them. Then, okay, what else? Some extra detail sideways. I think that's more than enough ideas for now. Let's start with a few random boxes. There. Sphere. And I'll scatter. Well, I'll just keep it like that, and I'll scatter some boxes on the sphere. So copy 2 points. Okay. I need to randomize the rotations and everything. So we did that before. Attribute, randomize. Not the color, I want to randomize the normal. On everything except the y-axis. Yeah. Just a bit less. I'll randomize the y position as well. So scale. Well, everything, nothing except the y. Not like that, no. So 1, 1 there. But this 0 is too small, so it's 0.5. No, actually 2 here. And 1 there. Yeah, okay, good enough. So the idea is to VDB this so that it connects, and afterwards we'll add some extra Vop noise to it. Okay, so we've got the basic shape. Let's call this basic shape. Okay, and now we'll do the VDB. So VDB from polygons. Okay, so you could lower or increase the voxel size, but I think this is good enough. I want things to be a bit chunky and connect to each other. So VDB, I'll do the reshape. And erode is good here. Anything with the mountainous shapes, erode works really good. So convert to polygons. Right, so I'm gonna lower this. Is it too much? Right, I just remembered Simon did the lattice. So let's do the lattice. We had it there somewhere. It's somewhere here. So we could Control F, lattice, deform. There it was. So Control C, and that's the best part about Houdini. You could just plug that in here and see the difference there. So we've got some. Let's go in and try to change the mount. Okay, what if I don't want to go in all the time? I could do edit parameter. This whole big window will show up. And these are the inputs, these four, but we don't need them for now. These are the inputs. I just hid them there. I don't want them to show up. So they won't show up here. If I hit apply, nothing. That's good. Okay, so I just need those two parameters, so I'll just drag them here. There, accept. So they turned, they're exposed now. Okay. Cool. Let's plug that in. Oh, we've got a hole in there. That would be a problem. I'm gonna change the scatter to. So if you scatter on a primitive, it will scatter on the surface, but if you do a ISO offset, it will scatter inside as well. Okay, yeah, that's fixed. I think I'd rather have this like that, and we'll go with something like this. I'll clip the bottom. Maybe before. Then fill. Put it to triangles. Okay. I think we're ready for some Vops. So let's just group that, call it VDB. Then subdivide a bit. Twice. I'll use the lattice another time. There. Okay. So what do we have here? I'll just copy this whole thing. Let's try it. Okay. I don't need that. No. Let's use the that noise, that unified noise. I'll put it to Worley. And we'll add that for now. Okay, it's too much, but it's giving that thing we saw here. This shape. I'll promote this variable. So we're just using the unified, and we're adding that. And that's the output. This is not being used. Go up, and we have, I'm gonna drag these, put them there for now. Copy, paste. So I'll just change this, put it to 2, not too much, 0.1, too little, 5, okay. It's happening everywhere, so let's just limit it to the bottom. And we did that with the relative bounding box last time. So we'll multiply that noise with a relative. Remember I'll show you that relative, the y, just the y. It gives you a gradient from the bottom top. So we'll multiply that gradient with the noise, so it only applies on the white area up there. So that comes in here. Instead of this line, it's gonna be this. Okay, so the bottom would stay put, and then the top would change. Go up, and let's try 7. Cool, now we have some sort of a rocky but also mountainous shapes. They could be in the distance, or you could keep them relatively low res and they would be smaller rocks, medium size or something like that. So the more detail we'll add, the bigger they'll seem. So I still remember one thing we saw earlier. We had extra cuts sideways. So we'll try to add that noise. We'll first try it on a simpler shape. So we'll get that sphere, turn it back there, polygon there. Okay, so we'll take this here, plug it there, and see the result. We'll experiment on this, and once we're done, we'll put it back in there. Okay, I'll delete these, and we'll play with the turbulence noise. We'll just add that. So position, we're adding turbulence on top of it. Let's add 3D. Okay, but I want 0 on the Y. Nope, I want 0 on the other ones. Yeah, something like that, like sideways. Roughness. Okay. Yeah. Maybe that noise added on top of this would look cool. So let's try it here. Ooh, I like that. Cool, now it looks like a sort of like a desert. And we could go back in and maybe add a little bit on that sideways. Oh, that's too much. 0.5. Okay, go back up. Cool. And what else we could add? Okay, I think that's more than enough for primary shapes and secondary shapes, and we can start adding the tertiary now. So this was the primary. This is secondary, also sort of secondary-ish, but now we could add the finer detail. This can count as secondary shape. And down here would be the tertiary. So we can add the tertiary all in here, or we could just do another one and change this, add it in here. So we'll do, let's try alligator. Actually, I'm gonna experiment on the sphere. It's just clearer. So alligator is 3 noise. I need more turbulence. Is it the turbulence? Or no, frequency. Yeah, there. Maybe that's good. Let's try it. Sort of. There. Yeah. I think that's more than enough detail. We have some topology issues. You could see they're going through there, and we could try to fix those. We could try to smooth, but then we'll lose some detail. I'll try it first here. And that's not enough to fix it. Yeah. We can always VDB again on a much higher resolution, but without the reshape. There. 2, 1. There. Now it's much more consistent. Then we can reduce to, let's say, 20. Okay, we did lose some detail, but it's way less in poly count, so that's good. But if you're using this for Unreal Engine with Nanite and that kind of thing, this is just perfect. You need to maybe use some vertex color, and you want to color this thing, we could do that. Of course, you lose the, let's say you had some color before, but you did VDB, you will lose that color. So we could attribute transfer. The transfer works based on relative position. With attribute copy, you need the points to match, point number to match, and point count. But attribute transfer works based on relative position. So if they're almost on top of each other, it tries to take that detail from the nearby points. But attribute copy, you need the exact same point number, but of course we're reducing, so we'll use attribute transfer. If you had some color before, that's how you get it back after VDB. But if you wanna add extra color and like detail and all of that, we could use the thing we did in the past here somewhere. Let's look for it. It's the what is it? There. This thing. Let's just copy that. And we can take all of this, put it there. Let's check it out. Ooh, yes, what is that? Oh, this is the manual paint we did. We don't need it. Okay. There. Now that I can call that a rock. And lastly, you could auto UV and export. Cool. Just like in Unreal, blueprints are made of C++. In Houdini, Vops, they are Vex. But it's not this whole thing. It starts, whatever you change starts from here. There. The rest up there are always the same. Alright, so it's Vex time. And I promised I'll explain this. Okay, let's try. I copied this, put it in here. And please just don't click off just yet. Just give me a second. Just one, just 1 second. Just give me a second. Well, I know this is what it looks. It's not what it looks like. Just, all right. It's text, okay, and some numbers. There's some commas and parentheses, and what is all of this? Okay, as an environment artist, why should I go through this hell? Like, why? And you're probably asking yourself, watching this video, why am I here? Why am I doing this to myself? But I think if you got this far and you saw what lots of cool things we could do with Vex, and we could also do them in Vops. But if you give yourself, let's say a month, at least a month, and actually try to go through this and really try to understand it, I'm pretty sure you'll enjoy it once you start making things with it. Okay, so where do we begin here? This is too much, so we'll break it down and we'll do one thing at a time. The main thing here, forget all of this. The main thing here is this line. It's color, which is CD. We use this a million times, and you see it in the geometry attribute. So we're changing the color. Never mind this syntax before it, we'll talk about this. So CD, and we're adding it, color 1, color 2, and color 3 to it. So we're adding these three. Colors 2, CD. And these three colors, they're this thing, that thing, and that thing. And we're grabbing those from other inputs, from input 1 and 2, input 2 and 1, there. The rest of this stuff are channels, and we use channels. So this is a float channel, and that's a vector channel. The first line, this was the color on the first input, this input 0, power is the same thing as multiplying something with itself. It's to the power 2 or 3. It's multiplying by yourself. So within this code, we're not actually calculating or where things are supposed to go, where the color is supposed to go. So these are happening in here separately. So this is calculating the AO, this is calculating the curvature, and that's calculating the slope. And all we're doing in here, we're just grabbing them and applying them in the same place by adding them together. So this whole thing up here, this is just, we're just getting those three values. We're getting them with the point function. Then we're adding and multiplying other channels, these channels, to them, and tinting their colors. And in the end, we're just adding all of them together. And you're probably thinking, well, yes, I get it. I get what you're trying to do, but I still cannot actually write this on my own. And in order to learn this language, there's only one place I could recommend. And it's the joy of, oh no, not this one. It's the joy of Vex. And this article or series is made by Matt Estela on CGWiki, and you could go to, let's start with it. I'll go for the first one. And it's a 20-day challenge. If you do one a day, it took me 30 days. I didn't know any coding language at all. But with this, I was able to learn coding and Vex at the same time. So I highly recommend this place. And let's try to do at least one of them together. And you can go ahead and keep going on your own. I'm a visual learner, so for me, this was a little bit tough at first. So what I did is I would copy this part, plug it in, see that changes the result, then I come back and read what Matt is trying to explain. So I'll just copy, do the thing, come back, see, oh, that's the difference. That's what we're trying to learn here. I usually prefer videos, but this was one of the best places I could find how to learn Vex. So let's do that ourselves. So we'll put a wrangle and I'll just copy this here. And we'll do that here. Okay. Maybe 20, not 50, yeah. Okay. So the first thing we need to do is color. So I'll just do that. I'll just copy this one. There. Cool. We got something. So what is it? Okay, so we're setting the color to the geometry. So this is the color and that's the normal. There's also another one. Let's try this one. Well, it's the same thing. What about if I scale it? Will it be the same? No, it's different. So with programming languages, when you write a line and you write another line underneath it with the same variable, you override it. So @cd was n, but now @cd is p. But if you do that, this is commented, so it's not doing anything now. It'll go back to the initial one. Okay, we can take part of the color, not everything. Just the X. The So if we turn the grid on, what's happening is X, position X, is the color. So this part here is negative. So we're supposed to see some negative values. There, the X, it's negative, and parts of them are positive. We could do the same thing on N, but it's doing the Y. So this is the normal. Whatever is facing the positive direction is colored white. The other ones are just black. What else? Let's copy this one. Okay, we can add numbers to them. That's what we're trying to do here. We're just adding numbers. We could also subtract, multiply numbers, subtract and multiply, but the order matters, so multiplication would happen first, then the subtraction. It's just quick maths. So what you could do is do things inside a parenthesis, so you could multiply. Okay, you could do things separately on different channels, so let's try that. So the color on the X is the position on the X minus a number multiplied by another number. Same thing here, same thing there. So on different, we're splitting the channels and we're applying other splitted channels, and look, we're using Z inside Y. So you could start swapping things, and these could be R, G, and B, and as well as here. It wouldn't make a difference because R, G, B, they're the same as X, Y, Z. So the channel, which is a vector, these are vectors. They can be split based on these. See, X, Y, and next to them there's X, Y, and Z, R, G, B, same thing. Okay, what else? We could color based on point number. So the point number is this, all the way down. So it's some numbers are, look, some colors, they're 4001. That's why they're fully white, and the first one, the 0, should be black, and the rest are white because they're above 0. But if we copy that part and divide by PT, okay, this is not gonna work because you need to convert that to a float. And we did that before, but we did it in a different way, and I'll show you where. Okay, that's cool. I think we could add this to the rocks. Let's try that. A quick side thing. Let's do that. Maybe not there, but okay. So I'm not gonna go through it, but you could see how this could split your rock shapes in parts and apply different noises, or so this is part of the power of Vex. It's just one line and it does this thing, and you could use it in multiple different ways. You could even split those as different UV shells, and just there's so many things you could do with Vex. But yeah, so I'll look for one thing though. We did convert to float in a different way on the line somewhere. Nope, not there. The line, where's the line? Yeah, there. So when we did this line, we converted to float by multiplying with a float. But you could also do this here, float, and actually force this to cast to a float. This, you could force the whole thing to cast to a float. Okay, this did not work here, so let's try it there. Yeah, there, it worked. So that first value needs to be a float, then it can be divided by an integer. All right, so what else? What else do we have here? Right, so what is this? So the point number is being divided by 100. Just 100? Okay, what? Why? We could, at any number, change the weight point. There's a channel. So now we're introducing channels where you could click that and then, oh, I see. So this would be a manual way to increase the noise on everything. And another cool way, you could actually run this on the timeline. You could just $F here, but the timeline is just 120, so let's multiply that by 10. And we could run this, and it just propagates along everything. And that, you could start animating noise this way with $F. $F is the frame. And since you have a channel, we exposed this channel here, we can start typing other expressions in here. So this is Vex, but any expression you type in here, it's called Hscript, Houdini script, sort of that thing. Okay, what else? There's sine. So what is sine PT_num? Oh, nice. So sine is usually a wave. It does this thing, that. So in here, it's going, so let's say that's the x-axis, and then you go, with a sine, you go up to 1, then below 1, below 0, it's -1, and up to 1, then -1, then up, and it oscillates like that forever. As long as there's an increasing value inside of it, it does that. And a cool place to check this out would be Desmos tool. If you Google Desmos and type in sine x, there it is. So if you're wondering about what type of function is this, or maybe you could just add to it, or see now how everything was below 1, but when you added, everything shifted up. But we could also, let's say, multiply it. And we know that multiplication scales things, right? We did that before, so we could scale even more. So we're oscillating much more because this is still inside of the function, but if we multiply everything by 2, now it scales up. So with this Desmos tool, you can start experimenting with these. So what we did in here, we did 6 there and 2 outside. So let's do times 6 and times 2. And we'll start to get some different weirder shapes. Because this is going on all directions, whereas on Desmos you were going on one direction, like left to right. But this is being calculated on a sphere. So if I Ctrl Z, there's not as much oscillation, but with more intensity and more power inside, we have more oscillation. Right, what else? And of course, just use this on the rocks, like extrude or like push out based on a normal, just the white areas, and now you have this strata strips look. Right, what else? So we can do a channel inside. So we're multiplying by numbers inside to change the sign. We just did that. What is that? There's scale. Oh. Cool. Of course, read these. Don't just skip them. I'm just skipping them for the video. Oh, sideways. Nice. So we're doing that based on the px, just one axis. Oh, and we're storing that in a float. So instead of just doing this and having everything on one line, what we're doing is we're storing this inside a variable called foo. Then we're using foo later on. And the reason it's on one axis, it's because px, not all p, not py, not pz, just px. I'm sure you've noticed by now there are two types of ways to initialize new variables and values. So there's this way and there's that way. By typing the name, the float name before your variable, this whole thing only exists inside this triangle. It does not go outside. You cannot see it here. The moment you do this at, things would start showing up in the geometry spreadsheet. And if they show up in the geometry spreadsheet, then you could use them later on in other nodes. You can call them and change them and do all that kind of thing. Okay, what about this? All right, so there's some exercises if you want to do them. And once you're done with this first one, you go to the next. There's some cool stuff here. Cool, so there's 20 of them. That would take about a month or so. Do as much as your brain can handle. And you'll become a different man or woman after you're done. Alright, we'll see you in the next video. Let's make a tool that takes a low poly and turns it into a high poly with different types of ways of doing it, with switches, and expose those parameters. Wrap the whole thing inside a subnet so we could reuse it on multiple different types of geometry, meshes, assets, whatever. So that's the goal. Let's begin. I'll put down a box. So this would be our guinea pig. This would be the example, but then we'll replace this with other stuff. Let's begin with a bevel and do a face-weighted beveling. Just that. With a normal. And this is set to face area. This is our first method. The other method would be the subdivision. Put that to crease, one more, right? And the last one would be the VDB. And now we'll put a switch. Maybe you could UV. Right, we need to lay out. I'll give it some rotation and apply some spread, scale. Right. For Unreal Engine, we'll need to transform this 100 times bigger. So we'll include that as well, but we'll give it its own switch. You could, if you want, go bigger. Divide to add this triangulation. Keep it on 3, but avoid the smaller edges. Okay. And finally, we'll soften the transforms. This will add normals. It's the same thing as this, but let's see the difference. There isn't much difference. So I can bypass this here. I don't need it. So this would do the face weighted beveling for me in the end. And if I had this come in here, we'll also have normals on this as well. And we could check for the normals. There, N is the normal, and it's that thing. Let's add one last thing here. I'll do a match size, and I'll do this at minimum, so this sits on the origin. We'll give this another switch here. There. Right. So the dotted line is not active. This line is the one that is working right now. So this is 0, this is 1, and that's 2, and so on. I'll just add a null here first. I can put anything in here and it'll add this soften look to it and get it ready for Unreal. I'll put this whole thing inside a subnet, Shift C, and maybe call it Enhance. Let's try another shape. We could do this solid, the platonic ones. I'll do a triangle. But I don't see the parameters there. Everything is inside here. I need to expose them somehow. So let's do that. Before, just to be safe, we'll put down an output node. Because without the output, if let's say I'm selecting this node, I'll bypass the output for a second and go up. See? So whatever I'm selecting inside will show up outside, unless I have an output. So this just makes it easier. I need to expose some of these. First, I like to change things. Let's say this, I want to expose that distance. So I would color this with the green. Same for these, I want to expose these. All right, that's everything. Go up, right click, edit parameters. So this whole thing would show up. I'll just hide these, we don't need them. Let's go in, go to the switch. So we need to select and drag stuff. Select this, put it in here. And this switch is for the match size, which is, let's check it. So it puts things on the origin. And I'll name it center. And it's set from 0 to 10, but all I need is just 2. 0 and 1. Because there's just 2. Right, bevel, I need this distance. And if you go to channels, it's set to the default. It's 0.025. And that's okay. Before I continue with the rest, I'm gonna hit apply. See how this turned green? It's exposed. That's why I color the nodes green, because they're sort of exposed. So let's check. I'm gonna go up a level, and now I have them. The center could either be on and off. 1 is on, 0 off. And the bevel, there. Control middle mouse to put it back to default. Right, let's continue. Go back in. The bevel, gonna put that here. Okay, apply. Go up. Now we have so many more. Let's try one of those switches. Yeah, so this switch is this one. Let's just name them. Apply. Go up. So the enhanced type is either bevel, subdivide, or VDB. The select, this scales up for Unreal. That distance, what is it? Yeah, this distance applies only for the first, the beveling. But this distance applies for the different. So instead of having 2, maybe we could link this here. We'll go back in for that. So this bevel and that bevel, instead of having this here, Control Shift left click, or just this delete channel. And here I'll copy this, paste it in here. And now I can get rid of the second one. Delete it, apply. Now one of them will control both of them. This just makes it easier. Too many parameters, things get messy. Let's put things in a folder. The left one is for the first 2, and the VDB is for the third one. Maybe we should do one thing first. I'll put a limit on this number here. Go to edit. Now I cannot go any lower than 0.01. The best thing about the enhance subnet we made is that we can copy it and reuse it on other objects. It's a formula, a function, a thing that sits inside a subnet which can be used and reused later on. But what if I went in and changed something in here? What would happen to the original one? Well, we could try. Let's say I completely destroyed the UVs. I don't want them anymore. Okay, so this one, whereas that has UVs. So this stays the same. They're not linked because it's a subnet. It's just it's sort of a group. It wraps around your other nodes. It's not gonna do any more than that. If you want to link all of the enhance nodes together so that they do exactly the same as always, we're gonna have to use HDA, Houdini Digital Asset. And we can turn these into HDAs. All you have to do is create digital asset. I'll just hit accept. These are the parameters we defined earlier. I'm good with them for now. Hit accept. Okay, done. I don't need this anymore. See, there's the unlock button. It's an HDA now. It's no longer just a subnet. I can save or match. If I match, it's locked. If I try to go in, it's grayed out. I cannot change things. I cannot, well, I can try. Permission denied. I cannot. So the nice thing about HDAs, I can look for them, enhance. So it's actually a node now. Well, and it says mo before because that's how I defined it when I saved it. And if I unlock this, allow editing, go in, remove the UVs, go up, save. Let's look at this one. This has no UVs as well. It changed inside. So all of these are linked. They're not actually linked. What's happening is they're actually the same file. They're no longer inside our file, inside this Houdini session, inside this whole thing we've been working on here. They're no longer part of this file. They sit somewhere else. Houdini has a special place for HDAs. You can look for it. We can go to type properties and look for it. It's somewhere there. And that place, you can see all the other HDAs. For example, in the past, I made an arrow. This is an HDA I made. And if I plug that in, it gives me arrows. I could do it from the point. So that's the box. Those are the arrows. And if I go inside, that's the tool. And it's grayed out. I cannot change anything. This is an HDA. I can go to another file and still be able to use it. I can open another file. Let's do that. Okay, that's a new file. Go in, enhance, there it is. Let's just check if it works. There, yeah. No UVs because we moved them to the side. Cool. There's one more thing we should address before we move on from HDAs. When you're making a subnet, it's best if you have a lot of parameters, it's best if you use a null and link those parameters inside this null. So this would control everything here, all the green ones. Instead of every time me going in here and, oh look, there's this one I need, and there's that one. And so instead, all of these would link to this one node, and this one node, I'll expose it and see it outside here. So let's do that. So any node you see in your network, you could go to its parameters. You can edit. This just has two parameters, but we can add more stuff. So let's add a float, hit apply. We have float here. Well, this is an integer, or let's do a toggle. A toggle is better for switches because you only need 2 here, but if you need more, you'll add an integer with a slider. So for now, yeah, so I added that toggle. I'll hit apply. This should show up here. Then I'll copy this parameter and paste it in here. So I'll delete that and paste that relative reference. And that label would switch. So I'm controlling it from this null. There. Okay, so I still need to expose this though. So if I open the... So when you use an HDA, it's no longer edit parameters. You don't edit parameters in HDAs, you edit the type properties because all the parameters got passed on to this other network here. So there is a difference between this and that. I know they sort of look the same, but the one on the right is we're editing parameters, but those parameters now exist inside this HDA. And it's just one part of multiple other things. And you could do lots of things in here, but we'll just focus on the parameters. And we'll no longer need this part because it's already in HDA. Those parameters are inside this section here. Whereas for other nodes, other regular nodes, you could still edit their parameters like that. Right, so we did one thing inside. We can no longer use the switch up here. If you try, let's try it. This switch is there. Yeah, the center one, it's not doing anything because the null is in control of it now. It's the label, this one. So I need this parameter. I need the center to control that label. So what I'm gonna do is I'll just delete this one. I don't want it. I'll get the label, drag it in here instead. And I'll call this switch. See how it says toggle? Apply. It's exposed. Go up. There, switch, switch. It works. So this workflow with one node that controls all the other parameters in the scene would be way easier to control. Imagine having all of this here. It's just, it'll save you time instead of going in and finding everything. So we'll do this one more time. Edit. So we're editing this node's parameter, just that one node. And I need a float. Well, I can try that. It's not gonna allow me, so what I will do instead, I'll use float here, hit apply, because I need this to control that, not that to control this. So this new label, let's name it bevel. Apply this bevel, copy it, and paste it in here. Let's use 0.25 as the default. So this is 0.25, go up. Except I need the type properties. So the bevel is this distance, and it will no longer work now. It's broken because we destroyed it. We need to get it again from this bevel. So I'll drag it in here instead of the distance. Delete that, accept. So the bevel there. And you go through them and do all of them, so you would have them in one place. And let's do the show selected nodes, and you can see how this one node is controlling this and that now, and it should control the rest of the green ones. Once it controls all of them, you can expose those parameters to the HDA itself, to its parameters. You could do other things such as hiding and unhiding parameters based on whether you clicked something or not, and expanding parameters. So let's look at that. So the recolor, it's, if I press on it, the color shows up. So this color, it says disable when, hide when. The RE color, which is this one, RE color, if the RE color is equal to 0, disable. So whenever this RE color is 0, which is nothing, this color is disabled. So you could use these other quality of life features here and there, but I do realize that as an environment artist, you would just throw every single parameter out there and use them without any care in the world. But this information is here if you wanna take it and develop tools in a friendly manner so other people could use them. But as you're learning, all of this extra buttons and technical details are not that important. Just get used to making HDAs. Make subnets, subnetworks. Inside of them, you do other nodes, and you control them with one null at the top. It controls all the other parameters in here. It has all the parameters. Then that subnet, you turn it into an HDA, you create a digital asset from it. Then you go to the type properties, and inside the type properties, you start getting all those parameters from that one null. So you can control everything in there, and that HDA later on, you would be able to use it in multiple different files. You can share it with other people. They can use it as a tool and work collaboratively on bigger projects. Let's talk about Hscript. Hscript sits inside of those parameters. Any parameter out there, you can control it with an Hscript. I'm gonna do another box here. So let's try it on this axis, $F, and you've seen me do this, but I'm just gonna multiply it by a small number. stay there. So the $F is the frame. We could do other mathematical stuff. So sine $F, sine, and put everything inside dollar. I'm just gonna delete that. There. Let's multiply that, the inside of it, times 10. Right. So we saw how the sine behaves. It's a wave up and down, and it's happening here. Negative 1 to positive 1. You could do cosine, of course, and other mathy stuff. Not just that, we could do center. We can find the center of the object. So let's say this was in the distance there. And if I try to transform it now, rotate, it's gonna rotate around the world center. But if I transform its pivot and move its pivot to its center and try to rotate, I can rotate around its center. So this expression down there on the X, Y, and Z, and now if I try to rotate, it will rotate around its center. Cool. There are other types of Hscripts, and I've written something about them. So let's try one of them. Let's try up name, this one. I'm gonna put it in the group for now. It doesn't matter where, it's just I'm gonna put it somewhere. So up name dot. Right, if I middle mouse, I can see the transform one. So it's reading its name, its own name. What if I do 2 dots? It's reading the geo, it's going up and then up another level. These are some expressions you could use to have more control over your parameters. We've used this once here, somewhere, no, not there, there, yeah. Part of this is an Hscript. So the $hip is an Hscript referring to the file itself. This is where I saved it. This is the $hip. Whereas I added also another expression, and it sits around inside this backticks. So this up input dot, and then there's 0. It's looking at that. See that extra line? It's going up and reading this name, and it's just switching it between with this up input. So whenever I export the name of the file, the place of the other files, and the name of this node. And you have so many others, so many, you cannot go through them all, and you don't have to. You use whatever you need whenever you want. These are very specific Houdini things you do every now and then, and it's good if you save them somewhere or write them in a note, use Keep, Google Keep, somewhere, just save it somewhere. You're gonna need it in the future. You don't know when, and you don't need to memorize them. Just look them up, copy, paste, and use them. Right, let's talk about loops. For each. These, they're all the same thing. You could click on any of them and then switch it to other type of for loops. Oh, so we have extra wires. I'm gonna turn them off. Hide. There. I'm gonna put down the pig. Put it to easy. Yeah, that's good. Okay. So let's extrude these separately. Extrude. And go just a bit. But they're connected now. I could do individual. So each one of these is being extruded separately, but they're all the same value. How do I change this value per primitive? So these are primitives and they're numbered. How do I extrude them, maybe based on their number or based on something else, on an iteration or a loop or something? I need them to be different. Well, what we could do is put this inside a for each primitive. There, right. It's still the same, with or without. Let's put this here, do another one on the side, compare. Not that big of a difference. It's maybe some shading, but there's nothing. This is the same values. So how can I use this loop to change the values per primitive? I need another thing that counts. So let's just look at it on a single. So these are all the other primitives being extruded one by one. Right. So I need this number, that number that is passing by, which I can get from here. Create meta import. So this extra node on the side will provide me that number, metadata 877. Because we have that many iterations. Well, it's a bit shifted because we start with, no, it's all right, 878, and then because we start counting from 0 there. So I need this metadata to drive the extrusion, and that's why we talked about Hscript in the last video, because we need it here. I need this parameter to change based on this metadata. So there is an expression which is detail, and it takes a few arguments. Let's look at that first. So I pressed F1, and the detail takes a surface node, attribute name, attribute index. Okay, so surface node is, what node are we looking at? So we're looking at this node, the for each begin. Let's go up outside of this node and look for the for each metadata. So now I have the surface node. I need the attribute name, and that is the iteration. Okay, it's gonna give an error because I clicked off. So if I go to this metadata, go to the detail and iteration, this value is the iteration number. It's the one that is always increasing. So I need it. I need that attribute name, and it's just called iteration, comma, iteration. Okay, I need a third and last thing. I need the index. So you can see an example here. It says the node it's looking for, the attribute, we used iteration instead of area, and there's also the attribute index, which is 0. Done. Okay, I can close that. And it's too much because we have 800 and some values are way in the distance, so we need to lower that way down. So if I multiply by 0.01, even less there. Okay, this is weird because some of them are 800 and others are 1, 2, 3, and 4. So some values would be so small compared to the big numbers. So instead, I'll use another function and wrap this whole thing inside of it. So I'll wrap this inside a random function, rand, and rand is from 0 to 1. So it takes any value and puts it between 0 to 1. So I'll even lower that, 0.3, there. So now I have some control over the variation. And we've used a for loop with some Hscript inside. So this is, save it somewhere, you'll probably need it. So the detail is the Hscript that is going outside of this node, looking for this node, taking the iteration from it, and this whole thing sits, we're putting it inside this other function, rand, which turns this value to a value between 0 and 1. Then we're multiplying by a smaller value, and you can keep playing with this value to get the result you want. You could play with these, switch to point, and do other types of loops. You could do loops inside other loops. But be careful with how many loops you nest inside each other, because for each loop it's gonna loop how many times, and then they stack. So, and then you would crash Houdini or any other software if you run loops inside loops.